Good morning, everyone. My name is Troy. This is an interesting group of really fine people here. I think earlier I was telling a few folks that they should change the name of the class. Instead of flares for experts, it should be flare discussions with experts, because most of you, as I scan the room, you have a rather solid understanding of flares already. And so, well, how many of you have taken the Flare Essentials class, the one-day Flare Essentials class? One, two, a couple of you. So some of you have never had one of our Flare classes before, and you're just going to dive right into the deep end of the water. Swoosh, here we go. All right, no problem. Welcome. It'll be fun. We're not in a huge hurry. In fact, one of the interesting things is at this level, we would like to slow down a little bit and converse. So if we get into something weird, strange, or unusual in one of the rules, and you say, hey, here's what we've seen, not at my flare, but at my neighbor's flare, they do some interesting things with their flare, and here's what's going on as an example, feel free to share, and maybe that'll help spice up the class a little bit. So we're not super rigid. Anybody know what it means to be pedantic? Pedantic. What's pedantic? That's a good word. Anybody?
In a teacherly fashion or instructing people.
Yeah.
That word has been used to describe me more than once.
Anal retentive, deep, follow every line, subpart I, double I, triple I, J, if you go down into the nitty-gritty detail, I'm going to work very, very hard at not being pedantic. Especially today, because today is the rough day. I'll be honest. We're gonna make you sweat it today. Sorry. Tomorrow is going to be a whole lot more fun, and then the last day is going to be all the miscellaneous potpourri topics that I think everybody is really kind of interested in. So first of all, my name's Troy. I'm in Atlanta. All the guys that are here with me are from Atlanta, except for Tom Goddard. Tom in the back, raising his hand. He's from the Houston office of SAGE. But Derek, Rashab, and Herman are all part of the Flare team. There aren't very many consulting groups out there that have dedicated the number of resources that SAGE has to doing Flare support work. So we took a little bit different view on the rule, and we hope it's being helpful. Some people, a lot of people, can give you advice on what is 60.18 and what is NSPS-J. And what is the rule? What's the definition of an interconnected flare system, right? A lot of people can do that. We wanted to be very uniquely different. And I have to admit, it has been a huge amount of work. It's been more work than we ever anticipated. And that is getting into the details of the instrumentation, how it all fits together, why it fits together. In Teron's case, why are there some interesting electronics that don't always fit together the way you want them to fit together? So there are some really interesting things that we've gotten to dive deep into, and we just wanted to share that experience. So it's been, come on in, we haven't even done introductions yet, so you're doing great. So we have kind of approached this rule or this opportunity with a unique perspective, and I hope you find some value in that. We don't want to just show up at your plant and talk about the rule. We want to actually be of some help and actually come up with a system that's going to work for you. So everybody laughs at my Gumby and Pokey down there. I know I'm dating myself, sorry. But if there's one thing about Gumby and Pokey, is that the word we use is super Gumby, super flexible, right? So I have an agenda. We're going to follow through some slides, but we're crazy flexible, okay? We will go down whatever rabbit trail you want to go down, and when I say I have no idea, which I'll probably say a lot, we're happy to open it up and let everybody share their opinion. That's what experts do. Hopefully a little bit of iron sharpening iron here this week, and we can all walk away with something new that we can use. So first of all, on the safety topic, it's a new hotel. Welcome to chaos, right? It's chaos is reigning supreme. So there is a bug in the fire alarm system. It's gone off 2 or 3 times already this morning. We're on the 5th floor. How many of you want to walk down 5 flights of stairs every time the alarm goes off? I would prefer not to do that. So we have been given authorization. Normally when we do a class, if the alarm goes off, we're out of here, right? That's our normal base. But today we have special dispensation that in the alarm goes off, we're going to listen for the verbal announcement. And if they actually say verbally to get out of the building, we will. Otherwise, we're just going to let it run its course, okay? And I hope that doesn't violate anybody's safety principles. If you feel you must exit the building when the alarm goes off, you may feel free to do so, okay? Meeting logistics, we're going to make it up as we go. We have never given this class before. We have never timed it before. When 10 o'clock comes around for the break, we're just going to, wherever we are, we're going to stop, okay? It's going to kind of flow however it flows. The other thing, just for fun, that if you want to go way down the hallway and find the restrooms, that's fine. But I believe there's a men's and ladies' room right here next to the fitness center, right on that little short hallway. So it literally is right around the corner. You don't have to go hiking too far away. We have water. Apparently we don't have coffee, which is like the end of the world. But there is coffee somewhere around the floor. I don't know. At 10 o'clock? I'm assuming during a break. Okay. Yeah, we don't know. There's many things we don't know, but a few things that we do know. All right, we got a few more people coming in. Scott, good morning. See what happens when you walk in a few minutes late? I know, it's like the end of the world. I'm so sorry.
It'll be a long time to register.
Everybody, this is Scott Evans and Dan Pearson from Clean Air. Hopefully you've heard of them before. And we're going to take a couple moments here and do introductions all around. So again, we were just giving the intros, Scott, that instead of being flares for experts, it's kind of like flare training with experts. There's more flare experts in this one room than anywhere else in the world, probably. So
No bomb doesn't go off.
yeah, that's right. Not allowed to be in the same room at the same time. All right, so Super Gumby, we're going to be flexible today and follow the path wherever it goes. On the Flare team, I kind of introduced everybody back there. We don't have to go through all this stuff. You kind of met the folks. What I'd like to do is introduce you. So if possible, it's just a small group. We're going to be together for 3 days plus all day Wednesday, right? So take your time, introduce yourself, who you are, where you're from, tell us any funny story you want to tell us. What do you do regarding flares, right? Are you a guy at the plant who operates the flare, or are you the corporate guru who's supposed to be all-knowing, the grand poobah of everything flare related? Fill yourself in wherever that spectrum is, and what you do and how you do it, and we'd love to hear it. Now, there's no time limit, right? So take your time. Dan, how about you go first? I'm going to point on you.
Okay.
That's what you get for walking in late.
All right, my name's Dan Pearson. I'm with Clean Air Engineering, and we've been involved with flares since actually before I was with Clean Air. But since I graduated from UT a few years ago...
We won't hold that against you.
Yeah, I've been working with primarily flares ever since. I do a lot of the project engineering for the passive FTIR testing that's been done in recent years.
Yep.
So the actual data collection.
Perfect.
Real life flares.
You're the one to blame.
Yeah.
He's the one collecting all that data that's being used against us. Stuart, how about you?
I'm Stuart Greiner. I'm an environmental engineer at Sinclair Casper Refinery. Do primarily air quality. Basically, our involvement in flares has been just trying to comply with JA so far.
Mm-hmm. Is it for the one Casper site, or do you kind of have the other sites too?
Mainly the Caspers.
Casper, okay. And is there other people in the group? I mean, you must have a team of people helping on. You have some instrumentation help,
yeah,
engineering help, and
we've kind of been transition on that. But have a coworker that does the monitoring end of it.
Gotcha. They all come to you asking you for answers.
Pretty much.
Yes, sir.
Sean Kirkpatrick. I'm out of Baton Rouge, Louisiana, with Vapor Point. We work with a lot of our clients that deal with the flares. We offer an alternative technology sometimes to remove sulfur loading, even in some project-based maintenance side, where we can kind of offer a alternative to go into the flare during those times for capacity issues or whatever. So anyway, I'll sit through the class where I have a better understanding when I work with the end users on the flare side.
So is that what people call, not sulfa treat? What's your fancy name for it? You have a
Yeah, it's just a high efficiency wet scrubber that we do. Yeah, there's sulfur treats aside. It's really just a either reactive or absorption process. Pull the stuff out.
There are a few refineries that are treating their flare gas with a scrubber system to remove the H2S so that they can meet the 162, right? So without flare gas recovery. So interesting stuff. I'm not sure if you've checked it out before. David.
Dave Tiffin, Chief Environmental Specialist at Formosa Plastics, Point Comfort. We have right now two elevated flares, 330 feet, 350 foot. We've got a permit for a third flare, which would be a triple three-tipped, 450 foot tall flare. We have 7 other flares in place. My chief responsibility up to now pretty much has been emissions inward TRI, release reporting. So I'm getting involved more in the permitting phases. So as we get into that, we felt we needed a better understanding of flares.
And you're in the chemical industry.
Yeah, we currently have 2 ethylene units, or olefins units. We make high density polyethylene, have 2 units, 2 polypropylene units, a linear low density polyethylene unit, ethylene glycol unit, chloralkali unit, ethylene dichloride, vinyl chloride monomer. That's what we make. And we have 2 utilities areas. We have 7 frame 7 gas turbines right now, 2 package boilers, a frame 6, and used to be a petcoke fired coal-fired plant. We changed that to natural gas with Eagle 40. So we've gotten out of solid fuels for that.
And these flares are 60-inch diameter.
Yeah, they're big.
Flare headers. These are
84-inch on the olefins 2, 60-inch on the olefins 1.
monsters.
Olefins 3, PDH will have a 450 foot flare with 3 tips.
You kind of rotate the earth one
Like having,
the rocket is pointing
Yeah.
right.
Yes.
Unfortunate occasion, we create a new sun. Yeah, but the olefins unit can come off about 300 foot tall flame in offset conditions. Yeah. We need to know more about flares.
Yes. Theron.
I work with, my name's Theron King. I work with Phillips 66 in Ponca City, Oklahoma. I work out of the reliability group, and my job is to basically ensure all of our analyzers are certified and all the data is valid and that they are maintained in a way that meets EPA requirements. Due to some quirks about a flare system we have in Ponca City, I've been working with GE for 4 years plus now, trying to help them understand what our issues were with our flare flow meters. And I'd be curious to know what you're doing with flare flow meters. With those size flares, that's a pretty tough challenge. But basically, I've become kind of the corporate expert on flare flow meters and analyzer systems for flares. And so I've been advising all of the other facilities. We have 12 refineries across the U.S., and I've been advising them on what to do, how to test their equipment, how to install it so that it works properly, and what to do with the data once they get it, sort of thing. So it kind of covers the gamut from
Yes, it does.
understanding the rule and helping them understand what they have to do, to picking the implementation, to installing it, to make sure it works right, and to make sure their data is good when they get it back.
Are you in the environmental group? Right. There's a unique thing.
I made a comment earlier.
Yeah.
And it's a unique situation. My wife is the environmental director of the Ponca City Refinery.
Yes.
I cannot report to my wife. That would be conflict of interest. They found me a job in the they found me a job in the reliability group. And so my job is making sure all of our analyzers are reliable and in good condition. And so I actually do 95% environmental work, but do not report to the environmental manager. Although I get about 90% of my work from my wife, and I get 100% of it at home. So.
That's great. Roger.
Roger Blanton with John Zink and Cross actually learned flares from Mike Keller at Calidus. And now our flare group sells flares, and I have a point not to use them. using flare gas recovery.
So Roger's going to have a little chat with us tomorrow, or is it Thursday, on flare gas recovery compressors and making sure everybody knows what's the difference between a liquid ring compressor and all the other options out there, just so that you can speak the right language. Bruce, everybody should know Bruce.
Bruce Davis, I'm DuPont's internal flare expert. Been involved with flares since '78, mainly involved with flare test work, and I'm going to present on Wednesday. But I troubleshoot flares, specify new flares, help the plants when they're replacing flare tips, step in when we get legal supervision.
Which it maybe is a lot lately. I think all of us are getting a lot of legal supervision lately.
Well, don't you know the science is settled and the problem is solved? We have refinery flare parameters. We don't need to worry about anything else, right?
All right.
Yeah, my name is Rick Vickery, and up until about February 1st, I was in Bruce Davis' group, DuPont Corporate Environmental Consulting Group. I'm based in Wilmington, Delaware, the DuPont headquarters. Now, with the spin-off subsidiary, Chemours, the chemical business spun off of DuPont. So I'll be the air quality consultant for the new company. So I thought I needed a little more training on flares so that I could help our sites comply with the regulations that come up.
There will be one or two issues that pop up from time to time. Derek in the back.
Hi, I'm Derek Stuck. I am Sage's primary flare PM. I've worked the last 2.5 years mostly on JA implementation, flare instrumentation, ECS integration of analyzers, and calculations of the heating value and such. Yeah, and like most of the Sage Flares team, I am based out of the Atlanta office.
Thomas.
Tom Goddard, the non-Atlanta player guy. 25 years out of school this year, so my silver anniversary. I started out my career with Union Carbide in Texas City with Troy. And so here we are, full circle, 25 years later. So petrochemical refining, I've been with Sage for 5 years. And it was actually early last year, I just kind of raised my hand, which we do inside Sage, and I said, I want to help with this work. So I'm very excited about being here today, and I have a little Quado module this afternoon I'll be teaching.
Wonderful. Rashab?
Hey, I'm Rashab Jaishankar, and I've been working with Sage for about 2.5 years now, and with the flare team primarily out of the Atlanta office. I'll be teaching the Flare Essentials class tomorrow, and yeah, looking forward to interacting with you guys for the next few days.
Herman in the back.
Hi, Herman Holm, Sage in Atlanta. I've been with the Sage Flare team since the start of the Flare team, so it's been a fun ride. I'm interested in things flaring, and I'm hoping to, I guess one of my biggest things that I always like to take away from these type of classes is I want to learn something new myself from you guys, so please, I'd like to talk about neat and interesting things.
Little known fact, Herman and Derek both went to Georgia Tech. So we got two really smart masters, Georgia Tech environmental engineers. Rashab went to University of Illinois at Champaign, and Tom went to Purdue. So we have this really great inter-office rivalry with Clemson, and this year Clemson got totally whooped by Georgia Tech. So the guys had great fun at the game, just pounding me. But I stood to the very end, right? I did not go home early. I did not walk out the door defeated. Dejected, but not defeated, yes. All right, over here.
Jake Kowalski, bar engineering. Started off at chemical engineer with background. Started off at Rosemount as an engineer up in Minnesota, primarily supporting Houston Chemical Alley. Then I spent about 7 years at Flint Hills Resources Pine Refinery, primarily on the air quality permitting compliance side. And been at Bar 7 years, and I primarily provide air quality consulting services to refineries. I've been following JA since 2008, the original rulemaking, and like Troy and others, final push for the flare management plans here, and November 2015. And I'm also looking forward to getting more involved with consent decrees, combustion efficiency, looking at RTR, NSPS, all that good stuff. So,
It's good stuff.
it's a good week.
Yes, ma'am.
Hi, I'm Wilhelmina McLemore. I work for the Michigan Department of Environmental Quality, the Detroit office. I'm an environmental manager. I've been working in the department for about 26 years. One of my staff inspects Detroit's only refinery, and they attend a lot of public hearings, and one of the hot topics of discussion is flares.
Yes.
I'm here to learn everything.
Have you been to this is the Marathon Detroit refinery that we're all referring to, so in full disclosure. Have you had the chance to go visit the site and walk down the flares and see all the cool stuff they've done? A lot of improvements recently. Yes, they've had a big expansion. So very happy to have you. Thanks for coming. Yeah. Professor.
My name is Yoshan Zhang. I have been in the air quality business for 25 years. Earlier days, primarily doing typical permitting, compliance type modeling stuff. But recent years, I have been focusing on two things. One is leak detection, monitoring. And we received EPA's Small Business Innovative Research grant to develop new technology. And we initially got phase 1, and then last year we got phase 2. And we have developed a technology to directly measure flare combustion efficiency. And we have done a full-scale test last November. I have a result actually in a poster, so if you are interested in seeing that tomorrow afternoon, you can see the result of that direct validation of the test, basically validation test to our technology. So you can see it. We have a way to measure the combustion efficiency, but we can also monitor the smoke, how much smoke is in the stack or in the flame. So actually combined with the two, Texas has been pushing to get incipient smoke condition, and it would be really difficult to achieve that without some way to see how much of smoke in there, especially during night. So now we have a way to actually measure it on a real-time basis. So I hope that will really help the operator to.
Well, you should have 25 of the most interested people in your topic sitting in this room. So I'm sure everybody's going to want to come see the poster and talk. There probably won't be enough time to answer all the questions. So really interesting stuff. I hope you all do take a peek at what Dr. Yosheng has put together. Yes, sir.
Yeah, Dave McMillan. I'm with Yokogawa with the measurementation division, and we make analyzer systems, integrated analyzer systems. I'm here primarily to understand the whole realm of flare management.
Well, welcome to the deep end of the pool. Yes, we're going to dive right in. Yes, sir.
Mark Allen, BASF. I'm in their Environmental Center of Expertise teams, and one of the responsibilities that I deal with is kind of a go-to person for flare help when our smaller sites don't have that functionality, and I help out with some of the bigger sites too when needed. So it's getting more complicated out there, I understand.
And which plant are you at? Or you're
I'm close to the Freeport site.
Okay.
But I'm in the Angleton office.
Okay, great.
Our corporate group is some of us are there.
Yep. If anybody ever wants to study the world's most complicated matrix management organization, BASF is the poster child for confusion. You guys are so complicated, I just don't get it, but I try. I keep trying. I keep trying. It's worth the effort. That's what they keep telling me. Yes, sir.
And all you want is a simple PO out of it.
That's right. It sounds so simple. It sounds so simple.
I'm Craig Tyndall with BASF also. Although our responsibilities are different, I am associated Primarily with our Geismar site in Louisiana, but I do serve multiple facilities because we have a hub concept, kind of this confused matrix.
Can you try that for us?
We have no time.
That's another 3-day class.
But we have a number of flares at the Geismar site and a number of complexities that we deal with there. So even though I realize refineries are kind of on the front end, as most people are aware, the chemical industry is right in line with EPA enforcement initiatives. So we have a vested interest in learning everything we can, and since that's my responsibility for Geismar, here I am.
Yes, great. Welcome. Yes, ma'am.
Danelle Zawoski from Williams. I started out working with this guy. And so got to do some really cool things with TCQ, but I'm actually now in Pittsburgh. So I'm probably one of the farthest one away. And we're in midstream, but we kind of figure that if we keep up to date with what's going on with you guys, then we'll be ahead of the curve. And so we've got massive expansion going on in the Marcellus. And, I have the only 3 plants with us up in the Northeast.
Okay.
So dealing with the hiccups of brand new gas plants.
And building new. Are you building some?
Oh, yes. If we're not building something, something's wrong. It's massive construction. We have a lot of new people.
Mm-hmm.
Yeah. I've been there for 5 years, and my employee number is one of the lowest ones there. So, by far.
Excellent. The man who needs no introduction. Everybody loves Russ.
My name is Russ Nettles. I work for TCQ. I hear a lot of good names going on flares right now. I work in emission inventory. We're responsible for collecting emission inventory. That goes into our modeling, which goes into our rules, which go into our SIP. It's very important that we get a good inventory. As an example, there was an over-assisted air flare with HRVOC instrumentation on it down in the Houston area. That one flare, it was over-assisted. That one flare was putting out as much VOC that's reported to us by the hour in all of the EPNs in Harris County. So that one flare was doubling the inventory where I work. So that makes it hard for our models to work and our SIPs to work and so on. So my interest in this is trying to help. I work for the government, but I'm here to help. I really am. To help everybody understand, we need to get those flares operating at high DRE, like everybody assumes they're operating. And I think we all will agree in here that they have not been operating at probably the proper DRE in the past. However, the emissions are getting a lot better. I feel we're not seeing near as many issues out of our regional offices with the flare cameras on the flares. Our monitoring network in the Houston area has been training down for everything, for all VOCs, including ozone. So good things are happening. And, my advice is we've been making fire for 10,000 years. It ain't real hard to do. So my goal is to get everybody to operate those flares correctly.
And the good news, too, is Russ is not in the TCEQ enforcement group, right? So he's very practically minded, and he's very helpful. And you don't have to talk about your flare. You can talk about your neighbor's flare. But you will enjoy, hopefully during the week, get a chance to meet Russ and say hi, if you don't know him already.
Yeah, I was fortunate enough to attend our flare test that we did at Johns Inc. in 2010, and it was amazing to see at the flip of the mouse it go from 99 DRE to 25. The flip of the mouse, just the flip of the mouse. Open that steam valve and it's gone. I mean, it was amazing to see. I wish everybody could have seen it. So, as a result of that, we developed some flare training. I don't know if anybody's heard of it. Who's not heard of our flare training? Well, we developed about a 3-hour internet-based flare training targeted to the operator or the person who's responsible for running that flare. We're responsible for turning that valve. And it's a good 3 hours. It's not, that first module was a little boring, but it's not so it's better than defensive driving.
That's a good analogy.
It's a little more exciting. But a lot of people take it. We got a lot of good comments on it. A lot of work was put into it. A lot of opinions. Probably the people in this room are in that training.
Yep. Awesome. Casey.
I'm Casey Stark, Chevron Phillips, Environmental Supervisor for Port Office Site. I'm here because I knew Russ was going to be here and find him and have a beer and talking about his flare training module and how to improve it. But, we just finished one of our facilities, got the 114 request from flares, so just say we have a vested interest to be here.
Lee Green, Chevron Phillips as well, and I'm in our corporate environmental group, and I'm working just on flares. A lot of it has to do with what Casey talked about. So 114's enforcement initiative, and then also the rulemaking and figuring out what makes sense for our company moving forward.
Grand Poobah you mentioned earlier.
Grand Poobah, yes. Now the real Grand Poobah is Scott, right? So now you're sitting in good company.
Don't do that to me.
Scott, would you like to have a few words?
I got involved with flares during the marathon consent decree. I've been on the negotiating team for most of the consent decrees that have been issued up until now. We also did all of the flare testing that, for better or for worse, has plagued the community for the last 5 years or so. I don't know, I just like big fires, I guess. Flares are cool.
And you walked in a little bit late. Welcome to the party. Would you like to introduce yourself?
Sure. I'm Gabby Holmes. I work for Nova Refining, one of HollyFrontier's refineries in New Mexico, and I'm here for the training because we're getting ready to for the new regulations.
Yes.
And so trying to get a little more acquainted with innovation. I work in their team. We'll work with departments there.
You should raise your hand. How many people have been to Artesia, New Mexico? See, there's a few. Yeah.
We have 5 flares in our Artesia facility and 1 more flare in our Bellevue facility.
And somebody, I don't know who, but somebody spent a lot of money to take beautiful photographs of the Holly Frontier refineries at night, which means that in the photographs, the pictures of the flares look beautiful. So we use them liberally in our presentations. So they have really great art. All right, so let's move on. Always follow the rules. The day 1 is a day that's going to be so painful. I dreaded this day because I know nobody wants to talk about this stuff. We will try to make it fun. Haha. And hopefully you'll find something interesting. Now, what was fun about the introductions, as I was taking count, nobody said they're in the landfill business. We have nobody in here with landfill flares, right? Any of the refinery sites or chem plants have landfill flares? You guys have one?
We have biogas.
Biogas flares, okay. There are some interesting changes in the rules there. We get pulled into some really bizarre things. So if it's a burning flame, for some reason they call Herman and ask Herman all the questions. So we're getting pulled into some really interesting stuff. We'd like to share what that is with you. You are an expert in your company, and so you ought to at least have some general understanding of what's going on in other industries. So we will touch on not just J for the refining sector, but we will touch on what's happening in California, what's happening in Texas, HRVOC. I'd like to touch on landfill gas, just so that you know the changes that were just proposed. Greenhouse gas, there's a really fascinating intersection, and the greenhouse gas inventory people are asking you questions probably at the plant site on flow meters. And I wanted to show you why that connection is happening, because they're wanting the same flow meter to give data for both the greenhouse gas climate change inventory and for J, JA, everything else. Tom has an awesome section on Quad O. Inside of Quad O, he's going to throw out a really cool example of what's happening in Colorado, which is turning into almost a model for what many of the other states are thinking about. And it takes the Quad O on steroids, right? So it really bumps it up. So really interesting stuff that I think, again, interesting connection points that you should be aware of happening in other industry. And the last one is MACT-CC, which of course is the new proposed rule, full of drama, right? Full of interesting things that I'm sure the guys in the chemical industry are really curious on what's happening in the refining sector, and you're hoping that they put up the good fight over some of these bizarre things that are showing up. So there is a way to do this. I don't know what the right way is for everyone, but we do kind of have interesting ideas on a one-by-one flare. It's hard to write a rule. Any of you have given this some thought for a while are realizing it's hard to come up with a one rule that fits everybody. So we are going to go through the rules. It is going to be a little painful, and I beg your involvement and interaction with me as we do this. Tomorrow is going to be the fun day for those of us who like engineering and calculations and instrumentation and hardware and what it means in the real world and how do we make this thing work, because we're taking the idea now is not a SEMS, right? We're not collecting data for the purpose of just reporting data, which is what a SEMS does on your boiler stack. We're collecting data for the purpose of dynamic control, live action, right? The Turtle Man, you know, in Kentucky on TV. I'm not sure who watches Turtle Man on TV, but live action, all right? We got to be, Russ does. So my kids were amazed I even know who the Turtle Man was. So, how do we turn the data into live action? And it's not so simple, right? It's not so simple. Then the third day, well, actually Wednesday is going to be the big group. Thursday we come back for those of you who can survive all of this, potpourri day, and a whole bunch of interesting things. Some special topics and special speakers. Hopefully it'll be of interest, and should be kind of a fun wrap-up day. Long time ago in a galaxy far, far, far away, we used to burn in the pits. Some plants still have a burn pit. We've seen a couple. They're rare in the U.S., but we do see flares in the ground, right? Maybe in the oil patch you see them more than we see. Maybe, Russ, as you're out driving around, some of the oil and gas sites have flares kind of buried or quasi-buried or burned around. But in the good old days, we would torch off things just to get rid of the product, the material. And everybody circles back to that word safety. It's almost like safety is the ultimate trump card, right? For those of you who play cards, if you use the word safety, it's almost assumed that you can't touch the flare. And at the plant level, we hear that all the time. Don't mess with my flare. It's a safety device. And then you start asking them questions about their most important, critical, gotta have, don't touch it, flare device, and they haven't got a clue what their flare device does, or how it was built, or why it was built, under what conditions it could sustain itself, those kind of things. So if it's so important, why don't you know more about it? So it's a little jab, right? A little jib-jab both ways. And but back in the good old days, instead of venting things to atmosphere, let's burn it off in a safe location. Makes perfectly good sense. And everybody loves the flare when it's big and burning, and it's there for that emergency case. It's this low flow condition, right? That everybody, that's a really weak laser. Low flow condition that everybody really wants to have more interest in, and that's what we've been studying and talking about for quite some time. By the way, that is a really horrible pointer for a laser guy, right, Scott? That's kind of a wimpy laser.
I got a bigger one. Burn a hole in your screen.
That's right.
I can't believe those guys are up there.
No, that's
yeah, is that an awesome picture?
Insane picture.
No, it's insane.
Does anybody does anybody do this currently?
That?
Yeah. Yeah. Who would sign off on their plant allowing that, right? That's just bizarre.
They've got the foil suits on, right?
Yeah. So, have you ever seen Jiffy Pop popcorn? That's what comes to mind every time I see that. Yeah, it's pretty horrible. So why do people flare? There's a whole bunch of great reasons. Of course, we know this. And we want that flare for very large volumes at a very fast pace. Some of the ethylene sites we go to they add the catalyst, right? And so they don't want that reaction to go out of control. If they over add the catalyst or something gets crazy, they want to dump that entire volume of that reactor in like 4 minutes. Can you imagine? Thousands and thousands and thousands of pounds of material safely combusted at a nice distance in 4 to 7 minutes. So huge volumes needing to be directed quickly. So there is a purpose for these ginormous drive a semi-truck or a pickup truck through size pipe flare headers. They do serve a very valuable purpose. Controlling them at the low flow rate is obviously a huge challenge to us. And what's really cool too is to go back in time. This group is a great group because there's a couple, 1 or 2 gray hairs in the room. So we kind of remember the process, right? Some of us remember how we got here. And it's kind of important to keep talking about how we got here for the new folks who joined the team who don't know how we got here. And but using the flare as a control device was hugely encouraged. Remember that? We have small, low-flow streams, hydrocarbon. We don't want to vent them to the atmosphere. Where am I going to put them? I don't want to put a control device on every single little thing. I can't dump it back to, I can't repipe the entire plant, so let's just put it to the flare header. So over the years, we have encouraged, and our rules have encouraged the use of the flare for these low-volume, low-pressure destruction ideas. So how many of you have gone through some of the items on this list before, gone through some of these studies? Some of you participated in these studies, right? So we get to give credit where credit's due. So this is really a fun thing. Now, I guess as a flare expert, you really ought to familiarize yourself with what happened in the 80s. Now, we don't have time to go through all of these. These are like wickedly cool fun to read because we start seeing words that pop up in their executive summaries or in their reports that we start seeing in other places. And we see words used like flame stability. That's a great one. What is a stable flame? And seeing those words as they're used, how they're described, and then what EPA's current expectation is to maintain a stable flame. Why do they say that? They say that because it shows up in some of the words used to describe these studies. A couple of them that everybody who has been through this before knows Siegel. I give the reference down here. It's written in German, so unless you have somebody on staff who can translate it for you, I know Clean Air has a German.
We have a German.
So it works out perfectly. So it's Siegel's PhD dissertation from Germany, from Karlsruhe University. What we like about this, what I like about his study, is that was 1980, is before all the flare stuff at the agency, right? Before the agency went crazy on studying all these things down here. It's on a real flare. It's not on a little Bunsen burner, who, by the way, I really like Dr. Robert Bunsen. He's one of my superheroes. But besides Bunsen being my hero, this is on a real size flare. It's not a make-believe flare. What's really cool, too, is it's a pressure-assisted flare. Isn't that interesting? It's a Coanda tip flare. So that's kind of a fun thing to remember. He is running what we would call low-flow conditions, low tip velocity, less than 16 feet per second. And he's using a variety. He's using a mixture. He's using the stuff that you guys would see in your plant. It's not a make-believe propylene nitrogen or some of these. Now, obviously, we know why the researchers used these very strict, well-known BTU content diluted with nitrogen. We want to know precisely what it is. But what's really interesting above the, I always get my numbers mixed up, 1,296 samples that Siegel took. Only all of them were at 99% destruction removal efficiency, except for 4 of the sample points were at 97. And he was doing some really interesting things. He varied a lot of stuff. He ran steam to vent gas from 0 to 1.5. He had a crosswind. He hooked up a fan to purposefully take the flame, tilt it on its side, and force the exhaust gas right through this little sampling array. That fan was running at, what was it, 6 meters per second or something, the wind velocity. I tried to compare this to the new momentum flux stuff. So it's all dead anyway, right? Scott says, don't go there, don't bring up that word.
Finally said revive it.
But some of these are really interesting. Now, those of you who are, here's a good question. Here's a quiz. Here's a test. Who read the Friday the 13th, last week, Friday the 13th Federal Register? How many of you, 1, 2, 3, 4 people. 4 people are aware of the Exxon Dow pressure-assisted tip velocity Federal Register notice, right? It came out on Friday. We'll touch on it here later. But Dow did a test on their pressure-assisted ground flare, passive test. I think the gentleman in the front row helped do that. Marathon did their test on their ground flare at their refinery. And Exxon is wanting to build a large array ground flare too. So in the Federal Register on Friday is a public notice that EPA is about to issue an alternative means of emissions limitation, an AML, to both Dow and to Exxon. And they base their rationale on these historical studies for things including, where is it? Here we go. The high pressure flare running at near sonic velocity, right? And the new passive test. So even in today's Federal Register, when you read stuff, they're going to keep referring back to the studies. Nobody has any intention of throwing the old studies out just because we have some new cool stuff, which is really cool stuff, right? It's really cool stuff. But we want the corroborating test, right? They corroborate each other. They don't disavow each other.
Sometimes.
And there's awesome details, right, to get into to find out when, when they crisscross each other. It's fun to know when and why. But these are important to know. Those of you who haven't had the chance yet to meet John Pohl, he still comes to conferences. He still speaks every now and then. He's an awesome individual. If you ever have a chance to meet him at AFRC or some other conference, that's usually where he speaks the most, right? AFRC. Really nice gentleman. He's quite knowledgeable. You should all take the opportunity to meet him while we all still can, right? So here's a study that Mark McDaniel did back in 1983. I like showing this one slide because somebody else is going to show you this slide. And that somebody else is an EPA enforcement officer, Robert Parrish or Pat Foley or somebody else from one of the regional offices. You will, if you're into enforcement, this will come across your table. So I just want you to see it before, yes? They were all respectfully invited, and we actually had a couple of them say yes, they would speak, and they gave us a yes, and it's all been withdrawn. So anybody, we're open and honest here, right? We have a couple state folks here, but we have nobody from EPA here. They have this funny, I don't remember this rule ever happening in the past. Maybe it's not a rule, this behavior. The behavior being, if there's a rule out for public comment or public notice, they prefer not to present on those topics during that open comment period because the law says I'm only allowed to take public comment via mailing in your public comments or at a public hearing, right? And so this is a venue that's not a public hearing, so they're afraid they're going to hear our comments and it may unduly influence their decision on a rulemaking endeavor. So we've had quite a few of them back out because of the Exxon Dow public notice that just came out Friday the 13th last week. So that's a bit disappointing, unfortunately. I don't remember it being like that in the old days, but oh well, times change, I suppose. But this chart from '83 is is the one that very clearly shows the steam to vent gas. I know you can't read that. Even in the book, I know you can't read it. As the amount of steam increases, obviously you get this precipitous drop. That's the infamous cliff that we all talk about. And the folks at EPA will allege that you should be operating up in this zone at all times, and when it drops, based on your steam to vent gas ratio. Now what's interesting is that this is one of those known or should have known. So right, the EPA will allege that there's nothing in the rule 60.18, we'll get to it, that talks about this idea, that that's a unique operating parameter. In order for you to maintain your flare with a stable flame, you should know this. It's just you knew or should have known. And we've known about it since 1983. Why haven't you known about it? So that's kind of the allegation. Yes, sir. Yeah, I know, nobody can. It is pound per pound. Steam to,
Relief gas.
it is called relief gas. And it is pound to pound, or kilogram to kilogram, actually.
So that ratio is somewhere around where the efficiency dropped.
Yeah, that's the curve that they established 3 as the cut point on 98%.
Yeah, so this is the 3 line right here. Actually, you have this little guy past beyond 3.
Yeah, it was 3 point, that one was 3.2.
And then you get this guy over here, which is near almost 5.8 or 5.7. So it's tough to make that into a DCS logic, right? It's interesting. It was one flare that had known this BTU content. There's a whole lot of ifs about this. But I guess the words that they throw at you in enforcement at the very beginning is going to be this little thing right here. The data suggests steam to relief gas ratios ranging from 0.4 to 1.5 yield the best combustion efficiencies.
If they left out the words for this particular flare.
Yeah, right. For this exact flare during these precise test events, right? So that's the allegation, that if you're running more than 1.5, you're in, quote unquote, the quasi-danger zone.
No, not from that study. There's data up to 3 that shows.
Yes.
Yeah, so what?
Exactly.
What's best from 1.5?
Yeah, that's right. It's actually pretty good.
Like the number 1.5, okay?
Yeah.
Well done.
Okay.
So interesting words. These words come back to us. Of course, it's not law. It's just an EPA report, right? By a contractor, nonetheless.
From the great city of Austin.
Yes.
Okay, so we've got a little data at the 0.4 and the 1.5, and then over at the 3 and a little bit over 3. The data's not quite as good, but it's still all in the high 90s.
Right. Well, remember, I always like to go back to the purpose of the test. The purpose of the test was to have a flame and put things into it and prove that if I add little gas from my fugitive emission components, my compressor seal, I'm adding low flow to my flare. So at low flow conditions with low BTU content, I'm going to have good combustion. That's what the purpose of the test was. So sorry, I just lost my train of thought on that. They always had a flame present. I don't know how to say that politely. They always had a flame present.
Because of where we tested it, we put out unburned gas. It was a giant safety hazard.
Right, so they weren't purposefully driving themselves from smoke to snuff. So today when we do consent decree flare tests, and the guys from Clean Air come up with all their cool stuff, and they take you from smoking flare through the incipient smoke point, good combustion, then all the way back down to I'm adding more steam, adding more steam, adding more steam. Where's the cutoff point? Smoke to snuff, right? That's kind of the words that y'all have been using. The older tests weren't really doing that. They weren't interested in going to snuffing. It wasn't a steam to vent gas ratio test. It was a I'm burning stuff in the flare test. And so uniquely, they always had a flare. they always had a flame, usually a visible flame, a present flame at the tip.
But Troy, their goal was to prove high efficiency, right?
Yeah.
Now, my issue with it is they turn steam off at those low BTU runs for most of the runs to achieve its high efficiencies. And that's what burns me up.
We wouldn't get smoke. With that mixture below about 500, 600 BTUs per scalp, there was no smoke.
Yeah, but you don't need to turn you can't turn the steam off on a flare, and it was turned off on these tests, and everybody, that looks like it was glossed over to me.
No.
They were still running at minimum steam.
Now they turned the steam off.
Turn the steam off.
We turned it off.
And, I mean, on our run at the Johns Inc. facility, it was at minimum steam, at our minimum flow rate, at our minimum BTU. It was like 46% DRE. That's the best we could get at everything minimum. We turn that steam off, it went from 46 DRE to 99.9. So what I saw from that is the hydrocarbon wants to burn naturally. Okay, it will burn very efficiently naturally as long as we let it burn. As soon as you start putting that steam or air on it, you start jamming that combustion ratio up, and the efficiency just goes down. Is my personal opinion on that. You know, so.
And
I'm tired of the A3 tests. Everybody throws that in my face like, ooh, do they turn the steam off to get those high efficiencies? You can't turn the steam off.
There's really a conflict there because flares are designed to have some minimum amount of steam, right?
Yeah, so you
And you have to have a certain amount to keep the tip cool,
Oh, yeah.
melting and all that. So how do we address that? Because you've got a low flow. It'll burn good if you turn the steam off. And is there a chance that you're going to melt your flare tip at low flows? Well, maybe not. I don't know, but that's something we need to talk about. Is, how do we go about addressing those situations?
Yeah, we have a couple other slides ahead on that, especially the diverging goal. There's a reason why people have center steam, and there's a reason why people have a purge gas through their velocity seal and molecular seal. And there's a reason why we have tip steam. But they weren't necessarily designed to optimally operate together. So
you can operate low BTU flares with no steam or no air.
yeah, we have unassisted flares all the time. There's a lot of unassisted flares. And their tips don't melt. Yeah.
What method did you use to do that test?
These were the extractive hoods.
This one, they had a probe hanging above the flare, typically about 2 meters above the visible flare. Test ran for half an hour, 45 minutes.
So this looks to me like on that E3 test, all the NOx and seal, all that stuff was about the same as what our test was. You know, we had $5 million worth of equipment there, and they probably had 50,000 there in 83, but the combustion, everything almost identical on the measurements. The big difference is turn that steam off to achieve that high temperature at the low BTU.
Yep.
It was very interesting to see that.
Those of you who are entering the world of a 114 or a potential consent discussion, you ought to find a couple of these reports because they will come up in your lawyerly legal conversations, and being able to know when they are applicable or not applicable and when they match or don't match might be of help to you.
Well, unassisted flare test there, and I'm going to talk about it on Wednesday, but it was the data used for the unassisted flare rule. Established at 200 BTU minutes, unassisted. And then the steam assisted flare work from this test, and then the subsequent PA test, resulted in a steam assisted flare.
Right. All right, so here's where we find some of these interesting words that show up in the executive summaries of most of these reports. The EPA conclusion, of course, was that 98% number. Everybody needs that number. We needed a number so we could do permitting, right? We can't do a permit unless we can do our emissions inventory. I can't do my EI because I got to have what number am I allowed to pick? So we needed some allowance that allowed us to use 98. And we start seeing these words of flame stability, stable flame operating envelope. It's unique to each flare. It's difficult for EPA to write a rule that mandates certain criteria for a stable flame because it's unique to every single flare and whatever gas is.
You know what the definition in the poll report is for stable flame?
The presence of a flame.
Yeah, if it's lit, it's stable.
Yes.
I mean, you know, people think about all kinds of weird definitions, but I mean, the definition that's used is that if the flame goes out,
it's no longer stable.
So that's all they mean by flame stability. And yes, there is a great dependency. If you don't have a flame, your efficiency is just going to go to hell. I don't know why they had to do a test to prove that.
Yes.
Apparently.
Flickering on and off.
Right.
That was considered a stable flame.
Some flames are not.
Some flames are.
I know, and I'm going to show you a picture of one on the website.
That'd be good. How do you show a picture of
I
invisible flame?
I show it at night, and then on the right I show it during the day.
And of course, the equivalent heating value, but different composition. Equivalent heating value, but different composition can result in a different view of that flame, right? It could be more or less stable or not stable, even on the exact same flare. So having a condition in the refinery setting where you're sharing multiple units using one flare, and different things are being directed to that flare from different process units, wildly different gases, wildly different compositions, does result in a different operating technique for each type of condition. So the chemical plants have an advantage here because usually there's 3 or 4 things that they're sending to the flare and that's it. Refineries seem to want to have one jumbo flare in the middle of the plant or 5 miles away from the plant, and they send everything to their big flare, and they really have a difficult time differentiating what's going to the flame. All right. I'm just going to touch on these really, really fast. Anybody have a facility in California covered by one of these flare rules? Phillips does. Anybody else? They've been at the flare thing for a little longer. And in fact, that's usually the feeling of comfort, if you want to call it that we give to the chemical sector, is that this is not a new thing. So feel comfortable knowing that people have been playing with flow meters on these giant flare headers for a long time. People have been trying to do H2S sulfur analysis on flares in California for quite some time, since the late 90s. People have been trying to do GC gas chromatographs in the Houston HRVOC program since 2004. So there are many hours of experience dealing with instrumentation and flow meters, and a lot of people immediately just fall apart over the instrumentation piece. So rather than retread all that ground over again, it's fun to go back and see what other people have already created. So we're not recreating everything. We do visit some plants, and the process engineer or the project engineer feels he has to or she has to recreate a PhD research project on a flow meter. Like, well, you can go through and evaluate the 13,000 flow meters and reconsider their pluses and minuses, or you can just trust us that at the end of the day, you're probably going to end up here, and we can show you the 3 or 4 people who do that, which are the most common ones. So that was what we were hoping to do with some of this. And this is just the introduction, so just know that there's a couple interesting state stuff. We're going to get into it deeper later. Everybody has seen and heard about this story. Is there anybody in the room who does not know the story of Ohio? Anybody? Everybody's heard this story, I think. This is the obvious case of over-assistance, over-steaming, 500-to-1 steam-to-vent gas ratio. The source of the emissions across the street at the school obviously are the flare that has no flame. It's hard to have combustion when there's no flame. How many of you have been to this plant? Has anybody been to the plant? It's in Region 5, Ohio? Okay, just curious. I'm just curious if it's still there or if they've shut it down and moved it. All right, how many of you got one of these? Yay! So as we understand it, the enforcement alert came out in 2012. You know, the 300 of these were mailed out. And so there's 150 refineries, 143, 147, depends on how you count them, got one. And about 150 chemical plants got them. And we actually did a FOIA request, US EPA. I wanted to know who got the letter, because those are obviously potential clients. So I have nefarious purposes for why I want to know that. They wouldn't give us the list, which was very interesting. And the reason they would not give us the list is because ongoing enforcement. What? It's just a notice. If it's just a notice, it's to the public, right? Yeah, did you guys know that if you got one of these, you're already under the auspices of being, I guess you're presumed to be in the enforcement arena, which I thought was really bizarre. They would not share the list with us. But we did get a little bit of information. 150 went to the refining sector, 150 went to the chemical sector. In the chemical sector, those 150 went to ethylene, olefins, basically all the olefins and olefin derivatives. Anybody that had some olefin derivative type process production unit. So it wasn't the entire chemical industry, just a smaller select piece. And of course, everybody's heard by now that, yes, it went from being a state interest to industry interest to a few spotted people being curious and interested in flares to Region 5 taking the lead on enforcement because of the Ohio exceedance, right? To a national priority. Flaring is a national priority for enforcement. That means money. They were allowed lots of money to train every region. So all 10 EPA regions have gone through flare training. Many of you are seeing 114 letters coming from the regional office first. A few of you are getting maybe letters from Washington, but most of the 114 letters are all at the regional level. They all look a little different, but similar. And we've had a couple of EPA folks actually sit through our flare classes as well. So they're very interested in how we talk about this. Yeah, Bruce. Which one?
You said that the regional people were all trained. Is that training package available?
No. No. I have no idea.
It was mostly just Brian Dickens sitting down with everybody. If you ask Brian, he might send you the slide. Okay.
But he had one or two reps from each of the 10 regional offices, roughly speaking. So yes, it's high on everybody's list. Here's the latest and greatest summary of the consent decrees. We'll go through these a little bit more on Thursday. Hopefully your name is not up there. There are what we call 5 flare consent decrees. A couple of these CAFOs. That's a consent agreement in final order. And the difference between a CAFO and a consent decree, very simply, is money and time. So OECA can sign a CAFO with you if you can close out all of the recommended actions within 1 year, and the penalty amount is less than $297,000, then you can sign a CAFO, which means I'm going to do all the same stuff, put in all this flare monitoring, do all these controls, but I'm going to be able to be done in a year. And that has a huge advantage, right? Nobody wants a consent decree that lives on into forever perpetuity. Everybody wants to get out of their consent decrees that they have now. Nobody wants another consent decree. So there's a lot of folks who are putting instrumentation in proactively, if you want to call it that, anticipating the fact that we might be down this flare CD discussion. And if that should happen, I want to be in a position where within the next 6 months, I'm going to program the DCS, we're going to have it ready to go. But for now, I have my instrumentation and my flow meters in, and I'm working on my steam control logic, but I'm really close because you want to be in that position to CAFO out rather than CD out. Unless, of course, the EPA says, no matter what you do, you're so egregious, we want a $15 million penalty, right? If they come at you with that, well, then there's nothing you can do. But at least on the action, you'll be at least a little bit ahead of the game. And by the way, what's really interesting is that the Shell Deer Park and Flint Hills are the the Shell Deer Park refinery and the Shell chemical site were included. So there is an olefins component, right, to 2 of the olefin flares on the Shell CD. That's quite interesting. And Flint Hills is all ethylene cracker. stuff. Okay, we'll get into that some more in a couple days. And here's where the logic kicks in, so it's a little bit different. We've been talking about taking flare, doing a flare test for net heating value, then people converting that into a flare SEMS, doing a continuous GC or a continuous BTU, getting data, and now we're not wanting that alone anymore. Now we're wanting to move that further down the line to this dynamic control concept. And that's the proposed changes in MAC-CC. So what you're seeing in MAC-CC is what is very likely going to happen for the rest of the chemical sector in time. We do talk about MAC-CC as its own section. Herman will do that. It's no longer April. Everybody can cross off April. Now I think it's more like June. I'm not, unless anybody's heard anything more recent than that. I've been hearing June as the target this summer for MAC-CC to be final. And that has, of course, a 3-year implementation cycle to it. So it'll take 3 years for everyone to go through chaos to figure out, I just spent all this money on a flow meter and my JA analyzer. Phew, I thought I was done. And now I get to go back to the plant manager and say, well, here's another flare project. And the management's going to be totally ticked off at us, I'm sure. So I think this is my last slide. Thoughts. Historically, we were interested in wanting to send more things to the flare, right? We were, because of the regulatory setup, we were incentivized under NSPS VV, LDAR programs, we were incentivized to put things into the flare header, and we wanted to use the flare. And that resulted in utilization during low flow. Everybody agreed that nobody wanted smoke, right? Have you ever heard anybody arguing, oh no, I want to be able to smoke my flare from the 5 hours straight? Nobody hears that, right? Nobody wants to smoke their flare. So there's pretty much widespread consensus on nobody wants a smoking flare. Everybody assumed that if I followed 60.18, I'm going to be fine. Everybody assumed that. You're not alone in your assumption of that. Everybody assumed that was the bedrock that we could all stand on. Clearly, there are flares. Clearly, we can come up with lots of examples. We've done it too. We have sites that don't believe us, and we say, no, you don't believe us? Come with us. We go to the control room. We actually, with the production superintendent, with the unit process engineer, we're outside, we're looking at the flare. There's a restriction orifice right there, right? If you turn off all the steam in the control room, you still have minimum steam to the tip, right? So it's safe. Trust me, we're going to do this. Then we go back to the control room, and you take their steam valve to 0, or as close to 0 as their controller system will let them. And lo and behold, it goes from nothing to a beautiful little ball of fire.
Are they surprised by that?
They're just totally overwhelmed by that.
I was. I mean,
They had no idea. And I said, well, how long have you been running at 30% valve open on your steam? And it's in the operating procedure. We've been at 30% open on the steam valve, you know. So you have the minimum RO and 30% open all the time. And some guys say, I've been at 30% for the last 25 years, and I've never seen a flame in 25 years on my flare. In 25 years. I've been an operator out here for forever. And you just lower the steam valve down, and voila, it's there all along. So yes, there are clearly examples of people who are adding too much steam. There is a lot of, and we can really have a sidebar discussion on this, right? Aggressive enforcement. I have to admit, and there's nobody here from EPA, and I'm sure they would take contest with how I tried to say this politely. There's a widespread feeling that this tactic somehow feels wrong. Right? That I don't. You all can share what words you wish to use and how you would characterize it. But the aggressive enforcement technique since the Marathon CD, since 2012, feels overly harsh. If there's all this information, why don't you change the rule? Why don't you help industry understand how to improve the rule and give us time to get there? Why the strong arm tactic? So that's a great discussion. Anybody want to jump in on that one? That's a little teaser. Yes, Mark.
Anybody else in the Baker Bots meetings last week? The Region 6
Thompson was there.
The question was asked, what would you like to see changed in the rules out there to help with all of this? And he scratched his head and looked around and he says, nothing.
Yeah. The rules are fine as is.
Perfectly. He didn't say this, but I read into it. I'm perfectly fine establishing the rules through enforcement.
Yep.
This is what I took out of it. So.
Yep. It's quite bizarre. And we'll have a chance to chat a little bit about it because the glorious, in my opinion, Troy's humble opinion, the glorious example of new information, a different way of looking at it, let's adjust the rule to accommodate a unique situation. The glorious example of that was in the DuPont case with the hydrogen flare. New information came around. It's a different take on the rule that came out in 1986. A few years later, let's do some more testing. Hey, we got some more information. Guess what EPA did? They changed the rule. They gave us the 8% hydrogen, right? So it's not unheard of that they can change rules. They do it all the time. It's just really bizarre.
And then that rule, 6 flares, saved us $2.8 million a year in natural gas.
Supplemental costs.
And for those flares to get them to perform like hydrocarbon flares. So it really saved a lot of money.
Yeah. So we go to a lot of sites and we hear a lot of frustration. I mean, not just an ordinary amount of frustration. There's typical EPA frustration, but an extraordinary amount of frustration on this one just because of the feeling that they're coming at this harshly. Some states are not like that. Some states are saying, yes, we know the rule is a little quirky, and we have other expectations, and we're going to help people do it. And one state in particular that's, I would label, more on the helpful side and less on the punitive side would be the state of Texas. Texas has done an awesome job, unlike any other state so far, in helping people understand this and helping people get their arms around it and not walking out tomorrow with the big stick to say you knew or should have known. So at the state level, there's varying degrees of enforcement, and obviously at the state level, really interesting perspectives on what the rules say, and we're going to touch on some of these things too, where some of the local inspectors think some really interesting things, and they need to be at least talked about so we can help each other understand. But the MAC-CC is finally setting the stage, right, for what future rules could look like, which is why it's so critically important that we do a great job writing this rule. And that's probably why there's a healthy sense of dissatisfaction with EPA in the current drafting of this rule, because we don't feel we're as collaborative this time as we were prior. Did I characterize that well? I was being kind. Am I being too kind? Okay.
The EPA did their test work. They had an expert advisory panel of about 20 experts that we met on 6-month frequencies on Jim. It worked well.
This time it's all behind closed doors and you don't know what it is until it shows up in the Federal Register. So it's a little different. Yes, sir?
I think I heard you speak on it before, but remind me, the EPA has certain rules, I would say, that they cannot visit with industry, or how does that work? I mean, they can't get any input from industry, they just write. And then they ask the
there's a 114 power, right? So they can send 114 letters every day, and they do, feels like, asking for industry for more and more information. What do you do? How do you do it? Why do you do it? Describe it, show it to me. And they can use their powers, their subpoena powers, right, 114, to gather that kind of information. And normally, in the past, that's what a 114 was for. Hey, you're in the yellow pages, and you say you make Portland cement, and I'm interested in Portland cement, so every Portland cement guy in the world, gets a letter. That's how it used to be done. And using the 114, like the refinery sector in 2011, 114 powers ask 1,000 questions because it's going to develop a new rule. Most people are okay with that. It's the site by site. Now you specifically, I'm sending you a 114 letter, and it's not because I need it for rule development. I'm doing it for enforcement reasons. That has a totally different flavor on it.
But in the early days, we would talk to the like in the leak detection repair rules, we organized 24 plant industry studies.
Mm-hmm.
Dr. Nate, okay, so it was an industry, EPA, and organized it. Same way it looked at on flares.
Yep.
And,
And now it's different, right? I mean, even the new MAC-CC has a fence line monitoring component to it. The refinery folks are aware of that. That was there. We knew they were thinking that way. They wouldn't do a collaborative test with industry, right? So API, AFPM did their own study with 12, I'm trying to remember now how many plants participated in that fence. 12, was it 12 sites? Collected all the data, summarized all the reports up, and hopefully the ERM guys will share all that if you haven't heard all this stuff yet. But it was the agency was doing its thing. Industry did its own and wrote a report that went into to the EPA, but it wasn't collaborative. It was.
in the old days, we would collaborate on it. They would meet, we would agree on the test scope, et cetera.
Yep.
We would both analyze the data, resolve any differences in data analysis.
Yep. Those of you who've been through enforcement discussions, and you probably feel that there's the way enforcement discussions are handled one by one, it feels that way too. It feels a little disconnected. So how do you know you're getting the same deal that the other client got? And how do you know that that guy is getting the right deal that's suitable for him? Because none of it is ever shared. Whereas when you do a rulemaking, it really does come out in the open and everybody gets to talk about it.
They won't even talk internally with the OAQPS.
Right.
People will not talk internally.
I'll have to get off my little soapbox on this, but when something as so critical as this and so impactful as what some of these proposals are, it'd be awesome if a group could have a little bit more push, right? A little more sway. And for whatever reason, we're not able to get that push through. AFPM and API are doing an awesome job, by the way, those of you who are members with those two organizations. ACC, American Chemistry Council, some of you chemical plant guys are in them. I think they're quickly jumping on board of this as well, so awesome. Can we take a break? What time is it? We have 20 minutes until the official break. So do you want me to talk for 20 more minutes?
I think that's the idea.
All right, don't throw stones at me. Oh, sorry.
Well, at least go 10 more minutes and then do the rush.
There you go. There you go.
Let's get the rush.
The rush, as in the rush, kind of like the signing in this morning for this. Actually, we could let out a few minutes early just to let people go officially sign in. Anybody not signed in? There's a few people who haven't signed in yet. Yeah, so maybe we'll give me a 5-minute advance warning. Wave your hand at 5 minutes till, and we'll let everybody out 5 minutes early. Yeah. All right. Sorry, you get me 2 sessions in a row. What we tried to do is split this up every other session so that I can take a break and Herman can talk, that kind of thing. And by the way, on your little, anybody not have a book? Everybody's got a book. We gave Derek top billing here. Derek stuck top billing on the printing, and instead of Herman. So Herman, publicly, we didn't mean to slight you. It was an accident. Everybody loves you, Herman. Everybody loves you. And I think he'll speak next. Subpart A. I get the easy one, Subpart A. He gets the hard one, MAC-CC and all the complicated stuff. All right, those of you who know, came out in '86. It's a general control device work practice requirement. And I've had this pointed at me a few times. It's not just it's not an emissions limit, it's a work practice. So EPA has the opportunity to suggest we do certain practices, maintaining a net heating value, maintaining a tip velocity, those kind of things. That's a work practice. So obviously it's been amended a few times, been changed, which I think is cool. That's what rules are supposed to do. We're supposed to keep up with how things change in this world. And we've changed it in the past. Let's change it again. the 4 pillars of flaring, or the 4 keys of flaring, or the 4 whatever you want to call them. Everybody probably has these on the tip of their tongue. No visible emissions, flame present at all times, adequate heating value, and a limited tip velocity. And then, of course, we get this cool little phrase that they throw in. Flares operated at all times that waste gases are directed to the device. Now, what's interesting is that the only reason I highlight this last guy here is in some of the other rules, landfills, oil and gas upstream, they say this differently. Right? It comes off a little different, and we'll show you these slight little wording changes. In some of the cases, it actually says a pilot flame shall be present at all times. At all times. And they don't give you this. So does that mean I have to maintain a pilot flame even if there's nothing happening at the wellhead or nothing happening at the oil and gas side, right? In Quado, you're kind of left wondering, well, wait a minute. What if I'm not doing anything at this site, then everything's out of service? It's not a maintenance shutdown malfunction. Am I shut down? What about, do I get the MSS exemption anymore? Do I or don't I? So a little confusion. So it's kind of fun to point out when the EPA misses that in their writing. All right, but these are the 4 things. I don't think that's a surprise to anyone. Now, this is where Troy's trying to not be pedantic, and I'm not going to go through the rule line by line, word by word. It's not too bad on this one because it's only 907 words. We could go through word by word because it's short. But if we do it for the first one, I'll feel compelled to want to go through Max CC word by word, and we'll be here for a month. So in the quest of not being pedantic, as a summary, comply with the provisions, shall monitor the control devices to ensure they're operated and maintained in conformance with their designs. Everybody in the consenting world, enforcement world, that's the hook. So that's why when they do a 114 letter, they're going to ask you not only for your operating conditions, your flow meter, your thermocouple devices, how often did the pilot light go out. They're also going to ask you for the design. What is the design? And that is a huge amount of fun. You guys are just a barrel of fun because it's amazing how much information you have, and it's also amazing how much information some sites don't have. You have been bought and sold so many times, and your files have come and gone 1,000 different directions, and finding some of these things that John Zink built for you back in 1973, or whatever they built it, or Zika, or whatever, right? We have no idea where it is. Some guy built it. We actually have found a couple sites with 5 different flare tip drawings. Well, which one is physically on the tip right now this minute? Don't know. I mean, we have 2 or 3 of them, and we just we refurbish them, we take them off, they go through the warehouse. That one's a Calidus, that one's a Zinc, that one's a Zico, and we don't know what's up there this second. And not only that, all the drawings are different. Oh, that one has 1,000 pound per hour minimum steam. That one has an 850 minimum steam. That one has a 1350 minimum steam. So which one do you have up there now? And is your RO coming in and out and changing every time maintenance does the turnaround? They don't know. So it's interesting how much fun stuff you guys have or don't have. But EPA is always going to ask for their design in their 114. What is your design basis? Most people are not able to come up with a design basis package, or they have one from 50 years ago, but not what's up there today.
Probably seeing even if you have the design, often they have what they're calling well, they don't call it minimum steam, but they have a recommended steam rate, which really is the minimum steam. Mm-hmm. And time after time, EPA interprets that as the maximum steam because the feeling is, well, this you have to operate at this 0.15. And you don't, obviously, you're always above that. But and yes. People have gotten penalized because their design documents have this recommended steam rate, and it has nothing whatsoever to do with combustion efficiency.
In fact, that's the word that they use in API 521. If you look in that column, in the table actually says required steam, not recommended steam. I think it says required steam. And that is that's even worse, because that's saying your own industry is saying the required steam is 0.4.
It's for cooling. It has nothing to do with combustion efficiency.
And of course, any applicable subpart will provide provisions later. So that in the general standard, we'll tell you how to monitor it later. And it's interesting how EPA never told us how to monitor it later. There's a whole series of further new source performance standards after the subpart A. And many of you are subject to a whole variety of them, right? Triple R, triple N, every alphabet soup out there on NSPS you're subject to. What do they always say? Must comply with 60.18. Do they ever add anything to it? No, they don't. They could have when they wrote NSPS triple D for polymers, right? They could have, but they didn't. So it does make it a little confusing. So not until you get to J, and now JA, we're really getting into some very specifics. And now I'm finally seeing some different provisions on how to monitor beyond 60.18. And I think, I don't know this for a fact, I can't read OAQPS's head, but rather than adjusting 60.18, for whatever reason they're afraid to touch it, I think they're going to do more and more of this. As more applicable subparts come up, more NSPS come up. That's what we're seeing in Quad O. That's what we're seeing in the landfill, right? Triple X. That's what we're going to probably be seeing in other things with the chemical sector. As rules come up, they'll probably change the subparts, not the basic. Maybe. We're not going to spend a whole lot of time on MACT because it's a mirror image, right? I'd love to ask if can anybody think of a difference between subpart A MACT and subpart A NSPS? I believe they're written identical, but I thought I'd have a whole room full of experts. I'll throw it out there.
They're close to identical, but the wording is very slightly different, but I don't think there's any intentional differences between the two, unless you found something.
I haven't found anything. Nope. Well, it's good to confer with everybody to make sure. But on the MACT side, it's going to bump you back. Same thing. All the MACT standards are going to bump you back to the general provision as well. So rather than going through both of them twice, I'm only going to do it once. Yay. Isn't that great? All right, key number one is visible emissions, and this is where I get back to. I don't think anybody's fighting over this. Nobody wants that. No industry is hoping for the opportunity for these days to come back again. That's pretty ridiculous. So, as far as we know, most people are not fussing over the visible emissions limit. There are a lot of curiosities about how EPA wrote the visible emissions standard. Must be designed, it must be operated, no visible emissions. Think about that for a second. How many of you have unlimited steam availability for your steam-assisted flare? Meaning, you have a 0 to 100% smokeless flare. 100% flare capacity smokeless. I don't know very many unless you're a pressure-assisted ground flare, right? So I guess the point is we have a lot of sites we have enough steam, the steam goes to the tip, and it's for 10% of our rated capacity. It's for 15% of our rated capacity. It's for 23% of our rated capacity, right? So I don't know of anybody who has 100% smokeless condition during all operating scenarios of their flare. There's not enough steam. we would have to have how many boilers running concurrently in the background, and they're just blowing steam out the roof, right? Yeah, Bruce.
You talked about earlier when the linear low density plant needed to relieve its whole reactor.
Yeah.
Union Carbide did a test on that on 2 of them simultaneously, and they went through the smokeless regime. It was 2 air-assisted flares. So they went through the smokeless regime on maximum air. It smoked for a time, and then at the high velocity, it shifted over to a pressure-assisted mode, and it went back smokeless. So for that case, when there was enough pressure to aid in the mixing itself,
right,
it reverted to smokeless.
And then after the 5.5 minute mark or whatever it was, then as the pressure bleeds down, then you go back through a smoky regime again.
Sure, and then the air assist would take over. But that's kind of a special circumstance.
We would always argue that would be a startup shutdown malfunction, right? During a malfunction, I'm going to get smoke. Because I wouldn't be planning the amount of steam I need during a malfunction. And the only reason I bring it up is, well, there's a couple of reasons. They're taking away our SSM exemption, okay? If they take away our SSM exemption and you read that word, plain English reading, right? Flares shall be designed for 5 minutes. Can you come up with a design scenario that gives you enough steam to not smoke for more than 5 minutes without an SSM exemption, right? I struggle with that one. So this is a huge thing that when the rules are being discussed and you are commenting upon them, something to keep in mind.
One comment, you say you haven't heard discussions about anybody wanting to smoke. The conversations that I have heard is the recognition that since the insipid smoke point is the most optimal, destruction efficiency, and we could operate closer to that, that there ought to be some more flexibility on that edge. So,
yeah, OAQPS and enforcement will come back at, yes, get as close to that incipient smoke point as you feel comfortable going. But the second you step over that line, kazam. And to help you not want to get too close to that line and to ensure that there is a kazam, that's why MAC-CC has these added features for even more rigid monitoring and visible. Even if somebody from the outside public calls you and says, hey, I think you got a smoking flare. Well, now you're obligated to sit there and watch it for 2 hours.
And then you can get into a very interesting discussion about what exactly is a smoking flare. When is it smoking?
Yes. So interesting stuff, that a little bit of Pandora's box in that we thought it was well understood. And now that we really start digging into the words, we find that there are some holes in the existing 60.18. And so our comments to a few folks have been, if you change the words of a visible emission inside MAC-CC, but you don't change it for the rest of industry, we're all trying to figure out, is that a smoking flare? Oh, it's smoking for the chemical plant next door, but it's not smoking for the refinery, or it is for the refinery but not for you. That's totally confusing. If anything,
change method 22.
Change method 22, right, because that's what we're referencing. Instead of referencing, you could make a few changes here, or you could just change method 22. In the back, John.
Are you going to speak to later this MSS? I've seen some permits lately that have the word upset. Maybe it's always been there. I'm not a permit expert, but I saw the word upset, and I'm like, I have no idea what that is.
Yeah, we in the permitting group, I think Randy Parmley was going to be talking to some of the folks during the permitting on words. Words are getting totally out of control. Startup, shutdown, malfunction, maintenance, upsets, periodic disruptions. A periodic disruption. Well, what does that fall under? I don't know what that falls under. On the permitting side, it adds a lot of complexity. On our side, what's an enclosed combustor, an open flame combustor? There's a whole variety of words coming out, and every NSPS seems to be written by somebody else that needs to come up with their own definition of something. So we're even tripping over each other on talking about things. A Quado definition of a combustor is different than a landfill definition of a combustor, right? We get some differences. Okay, let me, I got 2 minutes here and then I can shut up. I like to get through visible emissions. When do you do this observation? According to 60.18.
Initially, you're at the question.
Yeah, it's nowhere in here. There is no requirement to ever do this observation. When does it start? It always tells you how long it can last. So that's where you start seeing it written in your permit. A lot of permitting agencies put in a provision that says you shall do this daily. Maintain a flare log and do this daily. But if you go to a plant that has 5, 6, 8, or 10 flares, one flare may have that requirement, but the other ones don't. So it gets totally confusing. But nowhere in 60.18 does it require you to start this. Interesting. And again, no percent opacity. The person doesn't have to be method 9 certified to do a flare observation, right? tells you where smoke emissions are defined as occurring immediately downstream of the flame. Smoke occurring within the flame is not considered a smoke. Here's a great one. If you get an inspector that asks you for this, just be ready. This should be the indication that you're in for a bad day. If they say, where are the 2 stopwatches? Right? Where are your 2 stopwatches? Not using the computer and the computer video screen, or the I'm using my iPhone and the video up there, and I'm just looking at. When you mail in your smoking flare event, don't be surprised. A lot of attention on this. Thank you for giving us your smoking flare notice. Could you please tell me, because you failed to tell me, who was your observer, and what was the start time, end time? Because a lot of those notices don't include that. And if you get an inspection where they come out to look, they may actually ask you, show me the stopwatches that you use. And the next part is, the person conducting Method 21 should be trained and knowledgeable. Now, there's no requirement for a Method 9 class, no requirement for a Method 9 certification, but Method 22 says you should be trained and knowledgeable on these specific 5 things. And while you don't need a certification, Method 22 references written training materials such as these 3 things. Do you, at your plant, have this written up? For Method 22, who's allowed in your plant to do this? And just be aware that now that people are reading the rule with more interest and fine-picking every little word, these are what local inspectors are asking for, at least the finely tuned inspectors. That should give you a hint on the degree of frustration you'll have for the rest of the day. All right, we're going to take a little break. We left off on Method 22, and I would like to wrap this up and move on to a couple other interesting things. So let's keep moving forward. Some of you have a Method 22 training program in your plants, and you may be the environmental person who gives it to every single operator. But we've also found a lot of plants who just don't do any Method 22 training. They do Method 9. They send you off, right? You get to go on the trip to somewhere far, far away. That's fun and cool. And but you're not the one there actually doing the reading on the form that you mail in to the state, right? So interesting stuff that the agency is asking about. Key number 2 is flame presence. And boy, this is really fun stuff. Because the words are so important, and yet these words are so fraught with confusion. If ever there was an opportunity for the agency to say something better, this is a great example of where the words just got lost somewhere. Flares shall be operated with a flame present at all times. Why? Because without a flame, you don't have anything. You got to have a flame. It seems so obvious. But how could something as simple as the plain English reading of a flame present at all times, and you drive by and you see a bazillion flares, it feels like, with no flame at all. You don't see anything. That's why it's really important to have that little disclaimer at all times when waste gases are present or when waste gases are being directed to the flare, right? So that's a nice little thing to have in the rule. But what about this next little thing, as determined by the methods specified in paragraph F? So paragraph F, as we all know, is in regards to the pilot flame. So we all know that for decades, we have always said this, and it's almost like the choir, same song, second verse, a little bit louder, a whole lot worse. It's the pilot's on, I have a flame. That's all I got to have is a. So then we get to talk about passing combustible gases near a flame or through the flame, right? In all of the flare testing back in the 80s, they didn't pass the waste gases near a pilot and call that good enough. The combustibles had to actually go through the flame envelope. The gases had to be combusted. So at the end of this little method, though, you see this, they revert back to a different definition. The presence of a flare pilot flame shall be monitored using a thermocouple or other equivalent device to detect the presence of a flame. So which flame is this one? Is it the flare flame or the pilot flame? Yeah, that's right. So how do you know if you're reading, so which flame is this one? Flare shall be operated with a flame present at all times. What flame is that?
Redundant, or are they talking about a different flame?
They didn't specify clearly, so you get to pick, right?
So this is fun stuff, and it's circular logic, right? We'll never be able to get out of this little disaster that they created for us. With the current words. The current words are ambiguous. We all see that, right? We all see, you could argue both sides of the fence. And there are a lot of people who say, I don't have a flame up on top of my flare, but I have a pilot. In fact, I have 3 pilots. I have 4 pilots. I have a dozen pilots on some of the big flares. So I have plenty of pilots, and so I'm good enough. If I have 4 pilots and 4 thermocouples, and maybe some of those are even redundant as well, as long as 1 thermocouple on 1 pilot is okay. Have you all played that game? Yeah, right? So now you have a 60-inch diameter flare header. All the pilots are burnt out. Toast. Don't work. One poor little pilot is hanging on for dear life. And he only has 1 thermocouple left. And that thermocouple is drifting, and you're wondering what to do. So you run off and you rent a infrared detector, right? So I'm going to be able to prove that pilot's still with a remote infrared, because I can't get up there to fix my thermocouple. So you're going to come up with all these ideas, anything possible to not claim a Title V permit deviation, right? That's what we're doing. So 84-inch diameter flare header, or 60, and you have 1 pilot. How effective is that pilot?
Really good.
It's the best pilot in the world. Yeah. Here's another EPA question that has come up in enforcement. Is that 1 pilot operating according to manufacturer's design? Are the other 3 pilots operating according to manufacturer's design? And I know we're talking millions of dollars, right? We're talking shutdown. How do you get up there and fix this stuff? So there's money on the table. That's what we're talking about. Turnaround time, shutdown time. So you will come across these dilemmas, and I don't know the answer. You and your lawyer can come up with your own answer. But just so that you know, it is a common question. It comes up. If somewhere in your career this will happen, where 2 of the 3 pilots will go out, you're down to your last thermocouple. What do I got to do? And the plant manager says, I'm not shutting down unless you tell me I have to. And then, of course, the environmental person has this massive burden on their shoulder trying to express, here's the rule, and here's what it means. Here's how you need to make a business decision. And people get lost in this word. Well, obviously, that's not the flame. That's a pilot flame. And I have a flare pilot, the presence of A, right? All the lawyers are going to zero in on that right there. See that? A, the presence of a pilot flame. So I know exactly where the lawyers are going to go with you. I know exactly how it's going to end up. And at the end of the day, the technical person and the environmental person won't feel good about the decision, right? That's a business decision, right? If I'm saying something wrong, just let me know. But we've all been there, or many of us have been there before. So it's something for you to be aware of. Know the logic, know the conversation, be ready for it when your plant manager comes knocking on your door saying, do I really have to take a shutdown next week? And then you get to think about that. I like the idea of and I'm a pretty open and honest guy, I like telling on myself. I'll go ahead and tell on myself. Not every company does that, I realize that. Go to the agency. Some of them are really nice people, and they understand. And if you tell them, I got 3 pilots, 2 of them are burnt out, I have 1 that's going right now, it's going awesome, I'm ordering a thermal camera, thermal infrared device, it's coming, it's going to be here in 2 weeks, here's what I'm doing. Is this good enough for the time being? And maybe they'll cut you some slack and not call it a deviation. Other people just say, forget it, I'm going to call it a deviation. All right, fun stuff. Oh, by the way, monitored using a thermocouple or any other equivalent device. What's an equivalent device? Any other equivalent device that can detect the presence of a flame. At what frequency? Where does it say that? Oh, I don't see the word continuous anywhere up there.
And it would be equivalent.
Can I detect the presence of a flame once a shift? I'll have an operator with a pair of binoculars and he'll look up there. That's the rule. These are the only words I have to play with. I don't have any other words. I can't make up words. These are the words they gave us. So there are quite a few people who do not have continuous monitoring on their thermocouples. They don't. Many of you probably do, but there are places that don't. Are they violating the standard?
So are they have a local readout, a temperature readout, or just a local device?
Some people have no readout. It's just, right, not in the control room, meaning it's not continuously logged. There's a local readout down at the base of the flare or near the flame front generator or near.
Check it every once in a while.
They check it once per shift. People walk by, take a little data logger, or they do the little hand checklist thing.
All certified C2 is operating with a flame at all times.
Yeah, so how do, at all times, a flame present at all times, determined by this. So this is how I determine it. But there's no specificity on when. So there are clients, there are sites with thermocouples that read locally, not in the DCS, and they do it visually. And awesome, good question, right? How do you prove something's equivalent? You don't want to use a thermocouple, now you want to use something else. Mm-hmm. Yeah. Right. So there's devices that people have. We're going to go over those listing tomorrow, but there are acoustic devices that can listen for the flame. There are the infrared devices that can see. And there's obviously the thermocouple that can sense the heat. So there's other techniques. How do you know it's equivalent? Where does it say that the infrared finder, not the infrared camera, but the infrared pilot temperature is approved?
Well, if all it's got to do is detect the presence of the pilot flame, if that's the measure of equivalence,
Yeah.
detect the flame, it's equivalent.
So the word equivalency demonstration, does that ring a bell with anyone? EPA has this thing in we'll get to it here a little bit on, if you want to suggest something different, there's an equivalency demonstration or a waiver that you can ask for. There's a process to ask for an equivalency. And we went back in time looking for who's asked for or demonstrated equivalency on the infrared.
That's not what they meant.
Yeah, we can't find one.
Okay, good, thank you.
But everybody has them. Or your Title V permit probably says one or the other, right? Your permit will maybe override this. I'm just pointing out a little nuance in the rule that we come to agree over time, over the decades. A lot of people use other things besides thermocouples, and there is no formality around that approval. It just shows up in your permits over the years, but there's no formality around it. So which ones, according to manufacturer's design? Well, whichever one you happen to have bought and installed. So one could argue it that way too. Is that good air pollution control practice? Is a thermocouple good air pollution control, the acoustic, or the infrared? Yeah, it doesn't make a whole lot of, you could argue it a whole bunch of ways, but I guess if you come back to the basic words in subpart A, that's all it says. And from there, we have explored some options that you could do, and hopefully new options will come down the road, right? Hopefully there'll be new things, new technologies come along the line, and everybody wants to know, how do I do this equivalent device? What is an equivalent device, and how do I get approval for it? All right, moving on.
So if your flame is lit and burning, can't you presume that the pilot is lit?
Mm.
Have a flare flame. 24/7. And you've got that one pilot.
Yep.
But you've got the flare player. Can't you presume that pilot is operational?
Yeah, we've had that question, Bruce, on before. What if the pilot light goes out? The thermocouple still works, but the pilot's out. I still have a flame. Is that a violation if the pilot doesn't work? I agree. Anybody else have a different opinion? The pilot light is out. Maybe something broke down the ground level. Pilot gas isn't being supplied. Thermocouple's still sensing, obviously a lot cooler maybe than it would if the pilot were going.
What about the invisible flame?
The Harry Potter cloak of invisibility. All right, so there, we talked a little bit about this, infrared detectors. What do you do when there's a steam plume obscuring the line of sight? And that goes back to the frequency thing, right? How often am I supposed to, the presence shall be monitored? At what frequency? So what happens if during the morning hours when the steam plume is there and I can't see it, but I saw it later on in the afternoon at 2 in the afternoon? Am I out of compliance? The word continuous is not in there. Now what's interesting is the word continuous is in many of your permits. Now that's an interesting dynamic, right? Over the years, we've all assumed that the pilot has to be continuous, and it shows up in just about every Title V permit all across the nation. The word continuous is there. So you are bound to a continuous obligation, but it wasn't because 60.18 told you to do it. It's a deal that you accepted. So in some places, failure to have the pilot data continuously may be a state violation, wouldn't be a federal violation.
Enough data to show those kind of weather conditions makes infrared detector not very effective. Has there been an actual study on that?
I don't know about yeah.
The reason I'm asking that is that there's a substantial amount of even the pilot flame going on there, and it may have a chance to penetrate to some of those like fog and steam and all that. But I just don't know what level it's going to cause to problem. So I'm asking if anybody has experience actually seeing it.
We use one, and we routinely have at least 98%, typically over 99% availability of the monitor, so it's never been an issue.
Mm-hmm.
So fog is not. I mean, there's a perception, at least in my mind, is a perception that fog is going to cause a problem with the infrared sensor, but I have not seen the actual.
We occasionally have steam and snow occasionally. We usually don't have an issue with fog, but you can, but it's rare that in a blizzard we'll lose it for a few hours.
We have fog problems usually in the fall, but we also have cooling tower drift problems where the plume from the cooling tower in the wintertime is between the camera and the flare, and it will not read correctly. It's just too thick. It will read during the rain most of the time. It will read most of the time during snow, when it's real blizzard conditions. We've had that happen occasionally where, as a matter of fact, I understand it's happening right now because of snow already in the last 8 hours. So
what do you do in those cases where it doesn't read that 1%? Do you do some visual monitoring to cover that, or do you just count that as an
our approach has been to document the fact that it was out and document the reason that it was out.
And report it on your Title V deviation reporting.
As Title V deviation, or I'm not even, I'd have to think, I believe we do report those as Title V deviations. I'm not sure, I was just gonna, I made a note to make sure I looked at the continuous is in our permit.
Right.
I don't know that word is there, but we do keep track of those. Anytime it is reporting an outage when we think it's been caused by natural, weather conditions, we will track it, identify what we think caused the problem, and then when it comes back online, we just document the time that it's on.
Some sites are doing both. So they're in some of the newer installations have both the infrared sensor and the thermocouple. Some of the newer designs are sharing the technology, so they get some redundancy.
Turn off our flare to dissipate the fog.
Actually, Actually,
Roman candles.
actually, it does have some impact because if your flame is really intense, of course, the pilot is so small, it gets disappeared. But if you have a whole flame, it's not good because the intensity is so strong. It will be.
Yeah, get picked up by the camera.
Yeah, that little sensor has a focusing optic on it, right? So what are you looking at? You can adjust the optics, and if you're looking at the flare flame, it's always going to look hot. And you don't know, is that really monitoring the presence of a flame or the presence of a pilot flame? And then if you have a guy wire supported flare that kind of does this, you know, that thing's going to move a little bit of deflection, and then your little sensor needs to have a wider focus on it, right? So, yeah.
How many of you guys triangular or use multiple cameras?
Of the infrared?
Yeah.
Yeah, most sites that do this have two. Yeah, most sites have at least two. Unless it's a little flare. You guys have the one?
Well, we started with one, but then due to various
interesting issues, yeah.
We went to two.
Cheaper version, just to detect the temperature and nothing.
Threshold, you know, on, off.
Now we're going to enter another interesting arena, one that, another little trivia question. What type of flare is not subject to the net heating value requirements? So we're going to start talking about the net heating value. And there are some interesting things, and we have the experts in the room to help substantiate how all of this came to be. So there are some flares that do not require net heating value minimums, right? Interesting. Here we go. Net heating value. This is as it looks today. So we're not going to show the original version, then the DuPont study, hydrogen flare version, and then back again. So it reads a little funny. But the owner operator, you have a choice, and we love choices. We have a choice. Either the heat content in paragraph II and the maximum tip velocity in C4. That's one set. Or we can do the requirements in C3I. Now, of course, if you were in English class and you were writing this, you probably would have offered option I first before you offered option 2. But here we offer option 2 first before option I. I have no idea. In the way of the words, that's how they came out. And of course, option I is the infamous hydrogen story, right? This is really fun stuff. So here we go. Flares can only be used in net heating value of the gas being combusted at 11.2, 300 BTU per scuff or greater if the flare is steam or air assisted, or with a net heating value of the 200 BTU per scuff if the flare is non-assisted. Net heating value of the gas being combusted determined by the methods down below. Did the EPA take into consideration steam to vent gas during the writing of 60.18. There's no requirement for steam to vent gas minimums, right? Did they understand that steam could impact combustion efficiency?
Probably not when this was written.
No evidence of that in the rule.
Well, apparently, I mean.
I would say there's blatant evidence in the rule.
Yeah, I mean, you got a higher value.
Non-assisted is 200. Non-assisted is 200, everybody. Hey, if you're adding steam to it, we've studied flares all in the 80s. We're going to write a rule to accommodate the steam that we know you're adding. We're going to do a 50% bump. We're going to make you put 50% more BTU content in there. Now you're at 300 BTU per scuff.
Okay, so it's not really a ratio indication.
Yes, it's not flow ratio. Yeah, they thought they were addressing the problem. And silly me, I trusted them. Right? So,
the IRS do your taxes.
so when it's an interesting argument that will show up in your negotiations that I hope you never have to do. But if they do, the allegation is that you knew or should have known, and steam has an impact, and you knew or should have known. I like to throw that back and say, well, you knew that steam had an impact, and you should have known that 300 wasn't enough, or that 300 was dynamic, right? So the knew or should have known goes both ways. They knew or should have known based on their own studies.
What's their response to that?
It's never been nice. Because you know who I'm talking to across the table. It's never been a friendly conversation.
Well, they had those curves in 1983 showing very low efficiency, as you guys
Yes, it's obvious. So why did they choose 300 and not 425?
Or ratio.
Or a ratio. They could have picked 1,000 different solutions. I wasn't there back then, right? So I don't know. I wasn't in the room. But a lot of people say the current rules don't address steam to vent gas or steam assist. That's not true. They do. They wrote a bad rule, right? We all can agree to that. So when they wrote it poorly the first time and a significant industry sector had problems with it, they did testing. And back in the 80s, the DuPont studies, right? They changed the hydrogen issue by rulemaking. That's how we do things in this, well, that's how we used to do things in this country.
At the 300 BTU per scuff, I don't know if I'm talking about this tomorrow or Wednesday, I can't remember. It came from one data point on one test. So that's the number we've all had to live and die by for the last 30 years.
30 years.
From one single data point on one test.
Yes.
Okay, what about the other kind of flares that nobody really ever talks about, the pressure systems? So that's been kind of a question for us is like, well, we have a lot of sites that aren't 60.18. And it'd be interesting to talk about that.
If they're not, so they're natural gas, they're outside of Quado, they're outside of, they're not a, well, that's the trick, right? In the natural gas world, everything is being sucked into Quado, and thus an enclosed combustor or 60.18. So you're being introduced to these topics now for maybe the first time. So there are some historic.
In the parts we have it, but because of what we're dealing with some of the Marcellus stuff, we have high VOC content. And so we've been, for safety's sake, putting in flares on non-60.18 type situations. And so a lot of people are telling us pressure assisted is like the new better flare, and we actually have one now, and it's pretty dang cool.
Yeah. Pyromaniac at heart.
Yeah, but you know, I mean, that's the problem that we've been having is like, okay, pressure assisted probably for us is a better solution than some of these other ones, but it's like it's not addressed in 60.18, and that kind of.
Well, it is to a degree, to a point,
almost
but when you hit
excluded by 60.18.
Yeah, you hit the wall, right? Or you hit their ceiling based on their data set that only went to so far. And Scott really has a really awesome chart on this. I'm going to show you the calculation. He's going to show you a much better pictorial representation of it eventually, I'm hoping. Tuesday. So yes, let's talk about tip velocity, because that's what you're talking about, pressure assisted. So you have a choice. You have steam assisted, air assisted, non-assisted. So the EPA's interpretation is that we're wishing to create a fourth category called pressure assisted flare, and they're not going for that. They're saying that is a non-assisted flare.
So we have states actually putting in a fourth category.
Yes, and so as a non-assisted flare, you're going to see the tip velocity requirement has a different calculation. So I'm going to show you that.
So with this Dow and Exxon exception,
yes.
What are they calling it there? Pressure assisted?
Yes, pressure assisted non-assisted flare. They're sticking to their guns that it is a category of non-assisted.
Okay.
Good question, though. So a couple other interesting things. Net heating value, here's a good point. Of the gas being combusted, what's that?
Includes the steam? Doesn't include the steam?
We've always assumed is what you're sending to the flare from the pipe from the process up until this recent.
I'm going to show you the words to use with your inspector to help substantiate that. But that is the claim. that it is the waste gas in the header prior to the tip. So the net heating value of the gas being combusted is not steam assist or purge assist as well, right? The purge gas.
Steam's not being combusted.
Right. So interesting, and I'll show you why. And the why is right here. You have to go back and use this funny little calculation, and the net heating value of the sample, or the net enthalpy per mole of what? Off gas. Yay! That's my word. Off gas does not include tip, so I'm not taking a sample of the gas at the tip. I'm taking, according to their definition of what HT is, I want the net heating value of that sample, and it's per mole of off gas.
So you're saying the purge gas is not off gas?
Right. Some people do not. Some people add the stacked purge gas, after.
Usually it's added after the process entrance to the flare.
I love the word that you just used. Usually.
Okay, if you have a seal drum, you've got to have purge gas. But you also need purge gas in the header.
Sweep. Yep.
So that purge gas would be in the off gas, right?
Maybe. I don't know. I don't know, Bruce. It's a tough one because the not everybody has a water seal. Not everybody uses purge gas. Some people use their sweep as their purge. And so some people, when they do their 60.18 performance test, which I'm not sure even what that is, when they do their 60.18 performance test, they just take a gas of the header sample. Many of those have not included purge addition, which occurs sometimes in the stack itself, right below the velocity seal, and that's left out sometimes.
That material is usually what?
Can be either natural gas or inert gas.
So it could be in the chemical industry, we see a lot of this, that it's nitrogen. Chemical industry is very, very skittish about explosive mixtures and things like that. So we've seen people use nitrogen as their sweep, nitrogen as their purge, and that causes some really interesting problems. And we've seen, of course, natural gas, and then, of course, in the refining world, it's usually refinery gas or natural gas.
When we actually got a good look at some of our headers, we realized we were low and switched some of the, not only we back off on the nitrogen, but then we switched some of the nitrogen to methane.
Yes.
The way you figure it out, if you don't have a molecular seal, you've got to have the flow pattern to the pipe, so it's a velocity of 3 feet per second in the header. Or the base, so you have to be headed before that.
Yeah, 3 feet per second is kind of the industry, rule of thumb, right?
Right, but if you have a molecular seal,
then you can get down to half a foot per second.
3 feet per second in the header?
Right. No, in the stack for oxygen infiltration. I think we touched on this.
the widest point in the system,
Yeah.
which is usually the flare tip, but not always.
It's a little rule of thumb. It's nowhere.
It's in the API.
The HSEU calculations kind of end you up at that 0.5 feet per second if you have a velocity seal, molecular seal.
Can I get a reference on where that's at?
Yes, Herman has a whole presentation on it on Thursday, a whole section rather, a whole module on sweep gas minimization, sweep and purge.
Oh, in here?
Mm-hmm. Yes. Because we figure that's kind of important stuff. Especially in JA, the rule actually states, thou shalt do a sweep gas minimization assessment. And everyone's scratching their head saying, well, what does that mean? I don't know. Pull out the basis for your sweep gas injection rate, and nobody has those anywhere. No, a lot of people don't. Yep. By the way, a lot of questions always on this 20 degree, 25, and 20C thing. It's the gram mole, it's the volumetric. The volume value is based on 20 degrees. The net heating value of the combustion is at 25, enthalpy is at 25. And it's just built into this equation, right? It's built into that factor. That's the conversion factor. Everybody wants to know is, well, do I have to measure something at 20 and measure something else at 25 and calculate this when I do my DCS programming logic? The answer is no. We're going to convert everything back to STP, of course, but don't worry about that 20 degrees. It's just built into the K. That actually comes up a lot when we're doing consent decree word review. The lawyers get really confused over, why am I doing this? It's just a factor. Trust us. Okay, the other thing, the concentration that they want you to use and the net heating value, concentration of the sample on a wet basis as measured for organics. So that's the only word and only place in all the 60.18 that uses the word that even remotely connects itself to a performance test. 60.18 does not require a performance test. Just think about that for a minute. Another new source performance standard does. So if you have a triple R or a triple N column, a triple R reactor, a triple D process, and you have a closed vent system to a control device, that control device shall have a performance test, okay? It comes out of the NSPS. It doesn't come out of the general. So somebody says, I have a flare. I've never done a performance test on my flare. Shame on me, I better go do a performance test. What NSPS is requiring the performance test? Because 60.18 by itself doesn't. Now, 60.18 does want concentration as measured by a reference, method 18. There's a whole bunch of interesting things on method 18 we don't have time to get into, but a lot of complexity in there. And interesting, hydrogen and carbon monoxide are not by method 18. Hydrogen and carbon monoxide are by the ASTM method. Why is that? Anybody know? Yeah, method 18 is a Tedlar bag, and you can't do hydrogen in a Tedlar bag because it leaks out. You'll lose all the hydrogen. So they want you to use what's the fancy word? Electro-polished Summa canister. I can't remember. Herman's shaking his head. I'm on the right track. A special canister for the hydrogen. So what we find, though, is that a lot of people don't do this. The hydrogen carbon monoxide by ASTM, if you read your performance test, quote unquote, that you did back in the 80s or 90s, you hired some consultant to come out and do the test. More than likely, they reference method 18. And how they got hydrogen, I have no idea, but they don't reference these. So that has come up a couple times with a few nitpicky inspectors. You may have that question raised. But the most important thing is that's the only measurement, and then the rest of it is a calculation. So net heating value is based on calculation. There's only a method 18 test. Where does it say you have to have a 3 1-hour integrated sample? Don't have to always have 3 samples, right? I always take 3.
It's in the general provisions.
Where do I enter my velocity here? Is that in 60? The next section down, right? Yeah, now it does. Herman has a whole presentation on this to show you why we have certain problems with the way MAC-CC was written, or JA. And a lot of people are going down the path of I got to file for some amps because I can't do what it's asking me to do. I can't do. I need an amp. So what we want to do is show you there's an out for some of these that are already approved. And like everything in the EPA, that's the method. And if you didn't know the method was adjusted or revised or an alternative was allowed, if you didn't know that, you wouldn't know that because the method still says the method. They refer you back to the method, but they don't refer you back to the 18 exemptions they made for that method. So that's what Herman's presentation will show hopefully on Wednesday. We'll talk you through some of those things. It's pretty important actually. Yeah, I want to talk about that. What do people think about the wet basis? For collecting the gas and assuming, this is the collecting the gas on a wet basis during the day, putting it in a SumaCan, sending it to the lab. What temperature do they run their test at? What about those water condensables that fall out during shipping? Yeah, or at process temp. Yeah. Yeah. So in the consent world, there's a process. We'll give you 114. Everybody's totally stresses out and mails in boxes of stuff or 1,000 thumb drives with all the information on it. EPA reviews that, and you all stress out all over again, answering all the questions. And then finally, the EPA says, "I tell you what, whatever you give them, whatever you give them is not enough. Will you please do a sampling program and start grabbing samples from your flare header? How many samples would you like to collect, Mr. EPA? Well, just keep going until we tell you to stop. We'll tell you when you have enough." That's never a good conversation, is it? But then all of these questions come up. Well, what am I sampling? How am I sampling it? What am I analyzing it for? Under what conditions? And the rule's not crystal clear. So if the EPA asks you in a 114 letter, please go out and grab a couple samples for us, there's a lot of things to talk about.
They'd have to ask for a couple.
Yeah. A couple of months of samples, maybe. All right. Net heating value. Of course, what number do you guys like to use at DuPont for the net heating value of hydrogen? Is it the 274? There's a couple of things that bounce around, okay? If you don't meet the hydrogen's case, then of course we talked about non-assisted and steam-assisted. We talked about this one-time performance test. It doesn't specifically say thou shalt do a performance test on every flare. Another NSPS has to ask you to do that. And of course, the most famous one is anybody with a LDAR program doing VV or VVA, right? That's like the automatic welcome to the party. And what's always fun is when. When did that flare get invited to the party? I may have built it decades ago, but when did it become an applicable facility? In all NSPSs, the flare is never an affected facility, is it? The unit is the affected facility. So if I have a flare and it's in some process unit and it's subject to NSPS triple D, life is great. I've got to test my flare according to triple D, right? That's no problem. What if I build another unit? It's also triple D. It's a new affected facility. It's the affected facility. Do I have to go back and test that flare over again if I've combined the sources? Would everybody agree to that? That's the general consensus as well. When a unit becomes the affected facility, that unit needs a performance test that includes that closed vent system and that flare. Yeah.
LDAR affected stuff come all the time, clients all the time. Has there been anything addressing back and forth?
Yeah, we've investigated it but never came to a conclusion. So if you'd like to fund a forever research study, if you add a pump that has a dual mechanical seal or a seal that vents to the flare header, you added a new component to the flare header. The words in VV are frustrating, right? What's the definition of an affected facility in VV? Is it the component or is it the unit to which VV is affected? We get lost in the words. So now we're kind of like that movie Inception, right? We're going a dream inside of a dream inside of a dream. So we have embedded rules that are not following common definitions for us. So you're right. I don't have an answer because I don't know what the answer is. If I add a new component that's in VV, an affected facility, does that trigger another performance test? I don't think so. To me, that's not rational. To me, it's when a new unit, like a triple R reactor system or a new triple N distillation column gets added, then I'm in the game. But I don't know.
Louisiana actually defines that in the permit conditions to give you some flexibility.
On the definition of an affected facility.
You're
yes.
Creating a new affected facility.
All right. Okay, now we're going to touch a little bit on exit velocity before we come back to our trivia question again. Exit velocity. This is where it gets complicated. And it's complicated because there's a different exit velocity equation for different cases. So you get choices, and you get to move down this this little. I guess you could just always be less than 60 feet per second, and life is happy, and nobody will ever question you. If you go above 60 feet per second, there's a way to do between 400 if you have more than 1,000 BTU per scuff, and some of you who are in that game have BTU analyzers and some other things usually. The old days, we didn't even have the analyzer. We just got the authorization without an analyzer. Texas is probably the most consistent in that new flares being built, it seems like they're adding the BTU analyzer to every flare being built, even if it's outside of the HRVOC area.
We did that with MSS rules.
Yeah, it's pretty consistent. So if you had to pick a state, what one state has the most BTU analyzers, it'd probably be Texas. And I don't know if Louisiana is doing that as aggressively or not. So then you have this middle, or you have this Vmax calculation, right? So those are the, I'm going to just show you the, there it is. So maximum permitted exit velocity, steam or non-assisted, you get to follow the log rule. If you have high hydrogen flares, that's over 8%, right? They have their own cool little calculation. If you have an air-assisted flare, you get another Vmax calculated differently.
Then the question is on that Vmax for an air-assisted flare, how do you figure out the exit velocity for an air-assisted flare with the air coming in? How do you figure that out?
The combined tip velocity. Same thing, awesome question. Because nobody's doing it, right? With fan speed or fan curves. A lot of people have played with those with very limited success. If you have a success story, we'd love to hear it. Variable frequency drives seems to be the way that most people are going, and they're just getting rid of their one-stage, two-stage air-assisted flares. But even then, what value do you use for your air assist rate?
The real irony is none of this matters, because there's not a shred of evidence that high velocity has anything but a positive effect on combustion.
Yeah, which is the pressure-assisted issue, right?
Exactly.
The more motion, right, you have, the more you induce more ambient air into the flame, and it actually helps. And all of the testing thus far has kind of shown that. I don't know, other than history, why they're sticking to all of these, right?
That's all it is.
Low-voltage
Tradition.
flames do have slower flame velocities and will
blow out.
They will blow out.
Well, yeah.
So the low VQ.
As long as it's lit, though.
Right, and then the higher velocity case, it's limited by the test rigs or the test program, ability to test.
At that time, right.
So like I'm going to explain that on the hydrogen rule, the reason for the 122 feet per second max velocity on the hydrogen rule is limited by the test rig. That's the maximum we can test. So it has nothing to do with...
It's not like it falls off a cliff at 123. Yeah, there is no cliff, yeah.
No data.
High pressure. Right, so what most people have been doing over the years have been building the pressure-assisted flares, and in normal operations, that's the key word, normal operations, I'm less than the 400 feet per second. But to do that, I got to have a BTU analyzer at 1,000 that can measure I got to prove I'm over 1,000. So BTU analyzer, I'm over 1,000 BTU per scuff. I'm allowed to go up to 400. And then most people were arguing that if I go over 400, which I'm pretty sure I will, it'll always be at a malfunction.
A non-60.18 covered. So
Yeah, because now I'm in a malfunction case. I don't run there every day. I'm only going to run there when a relief valve goes off or some catastrophe.
Normally you would not design a flare.
Yeah.
From a design operating,
Yep.
you wouldn't design a flare at 400 feet.
Yeah. So the problem that you're going to have in your unique situation Is that in? Yeah. In natural gas transmission, they close in valves. They shut down compressors for routine. I'm going to inspect this compressor. I'm just going to shut in these 5 wells over here, just temporarily. Shut them in while I do my maintenance or my routine thing. While I'm locked in, I'm still pumping oil. I want all that oil. But the gas, what am I going to do with the gas? During that brief period of time, 2 to 3 to 4 hours, I'm going to flare that gas. And those flare rates can be 1,000,000 scuff per hour, right? Some of these flare rates during a block-in can be ginormous. It's not a malfunction.
I wouldn't even say, I wouldn't say we're doing that. That's more on the producer side.
Yes.
That's what they'll see with the producers.
But at the gas processing side.
That's kind of against some things on Quad O, but
Yes.
no, what we do is we have an engine. We block in each valve. When we go to start it up, we can't overcome the pressure that's between those valves, so we have to evacuate those valves so we can start an engine. And so that is very quick, but high pressure. Like they're gone. I mean, yeah.
And it would last for...
The actual, technically we were putting in that pressure assist flare was put in just for that. So it's normal operation above 400.
Emergency range.
And you can't vent it down over 30 minutes? You have to vent it in 3 seconds? You can't vent it over 30 minutes?
When we have ESDs that do the whole site, and those are emergency, but for the engines, doing over 30 minutes.
It's a startup sequence, right?
Yeah.
So it's a startup emission that's unique.
Keep the velocity down.
So as long as you can still claim the startup, if you claim that that event is a startup emission, maybe you're okay. Until they take away your SSM exemption.
Like the pressure assisted one seems really good.
In which case you're going to want to apply for the same MDL that's now next on
Yeah. Yeah, we don't have we don't have a presentation for it, I don't think. But I do have a list. We've done obviously quite a bit of work on the pressure assisted front. So there's 18 ground flares in the US today. How many of those have an approved alternative means of compliance, or approved AMP, or an approved AMOC, or an approved AMEL? And one of them is even approved by an applicability determination index thing from way back in the 90s from some crazy engineer from Huntsman who wrote that thing years ago and got it through the system. Yeah, how did that happen? So we thought we had a way to do it back then, and it was easy, and now it got complicated. So what used to be an easy system to ask for now has turned into this ginormous AMEL thing that Herman will show you Wednesday, I think. Yeah. All right, high hydrogen flares, 1998. And I think everybody knows what happened. The most important thing to me is, again, the process. There was a process, and we got to collaborate through getting the high hydrogen flares over 8%. Anything over 8%, high hydrogen doesn't have to meet the net heating value requirement. This is a really bad picture. Probably doesn't show up too well in here. Propane flame, hydrogen flame, same, if I'm not mistaken, it's the same flow rate, blah, blah, blah. It's everything that you know. The hydrogen flame doesn't have a flame until you look at it at nighttime with special secret decoder glasses or something, I don't know. But it doesn't mean that it's not there. High hydrogen flames have their own little equation for maximum permitted tip velocity. So non-assisted, high hydrogen, more than 8%, have to have more than 3 inches. And of course that came because that was the dimension that you tested. Does that mean a 2-inch flare is not good? No, it just means that that's what they didn't test a 2-inch flare, they tested a 3. Yeah, designed and operated, this is where that magic 122 comes from, follows its own little curve, right? And here's a fun thing, 60.18 allows that flare, as described above, high hydrogen, non-assisted, greater than 8%, As long as you meet that tip velocity, no net heating value requirement.
Essentially, you replace the net heating value or the BTU content with hydrogen content.
Yep.
You've got a hydrogen requirement instead of your BTU.
Yes.
85% hydrogen and nitrogen is 29 BTUs.
Better than that.
2930. The BTUs parameter just doesn't work for this composition.
So let me throw out something and see if all the experts, what you think. I have a refinery. My refinery has a hydrogen unit. That hydrogen unit makes more hydrogen than I need. Uniquely, I don't need all the hydrogen. I'm going to purposefully put, continuously, 10% hydrogen into my non-assisted flare.
Absolutely possible.
If you could do it without smoking, etc., you could operate to the 8% rule in refineries. Now, refineries rarely flare. The other part of the hydrogen rule, when they're testing for it, it's not assisted. So the way the test was set up, it's less than 5% hydrocarbon. The feed non-assisted. Because if it's got more, it starts to smoke.
The 5% hydrocarbon.
5% hydrocarbon, yeah. So that part of it didn't get in the rule, but the test makes 3
Yep.
tests, that's how it's set.
Yep.
And there is a paragraph in the report that talks about it.
Yes.
So
That would be an option, though. Is to
right, but refineries rarely flare hydrogen-rich hydrocarbon lean streams, and their hydrogenation units are rarely hooked up to a flare directly. By the time the hydrogen-rich gets down to
Yep.
flare, they basically don't use the 8% volume. And it wasn't very important to them in the comments.
Yep.
In the comments, they were silent on it. API.
Yep. It could be possible.
It could be possible.
Yeah. What about a olefins plant that has high hydrogen?
We have some periods of time during the, on our big flare, when we're flaring hydrocarbon rich, we operate, so there are times when we operate both.
we need to reevaluate compliance based on what mode of operation they're in at the time, 8% or not.
Right. The problem comes where if you operate the hydrogen rich, you need a lot of natural gas unnecessarily. In other words, when you do the calculations of the natural gas you need to drive 8% hydrogen to 200 BTUs of scuff, it's a lot of natural gas.
Right.
So it's like a third of the flared gas. Okay?
Right.
You don't want to have to adjust the fuel composition on a hydrogen flare.
All right. So that's your trivia answer. What type of flare is not subject to net heating value? High hydrogen, non-assisted. Thanks to DuPont. And industry group that all supported the creation of that rule, right? It's not, we don't want to give, too much credit to DuPont. We got it.
It wasn't a cooperative deal.
Yeah.
Those what you're saying there is that all of the flares operating in processes that are covered by otherwise applicable 60.18 rules, these types of flares don't have that requirement.
I guess what I'm saying is we do find some chemical plant sites with high hydrogen and low hydrocarbon that could be non-assisted flares. That could meet this thing, and they're struggling on how to meet the 300 BTU. So just reminding them that they have options. They don't. So everybody in the world doesn't have to be at 300, I guess is the point.
I believe if you had a steam-assisted flare with these conditions, you could turn the steam down to its minimum cooling steam flow for the nozzle and operate it to the 8%. I believe you could do that. Now, Russ,
Yeah, I'd have a hard time believing you'd be able to go with that.
Yeah, I think it's the non-assisted high. It's the linkage.
So you'd have to turn the steam.
You have to be non-assisted. Now, what you're saying is it could be non-assisted for that period of time. If you turn it all the way off.
Right.
Yeah.
Then maybe.
Then you violate your warranty of
So this is my one-slide teaser to build up Herman. in his talk, alternative monitoring plans. Obviously, subpart A contains this provision in 60.13 that says, hey, you can petition the EPA and suggest an alternative. And those of you who have gone down this road are probably all frustrated as heck over what words are we talking about. Are we asking for the waiver? Are we asking for an equivalency demonstration? Am I asking for an alternative monitoring plan? What am I asking for? And another part of the rule is going to ask for an alternative means of emissions limitation. Those are the 4 federal words. So what you're going to see in the February 13th last week is that when we did the thing for Exxon, we asked for everything because their rules were so confusing. We didn't know what to ask for, so we asked for every single item in the list. We asked for everything. And of course, they picked the most stringent, which is the alternative means of emissions limitation, which requires a Federal Register notice. Yes. Yes, it's similar. It's again the EPA saying, hey, if you have a better idea, you can always petition the administrator. It's the words that they use to describe how do you ask, and it's different. Mm-hmm. Right. And we'll go through those lists in the emissions measurement section, the emissions measurement center that approves changes to the EPA methods, and then there's another way to petition EPA on the monitoring instrumentation or the approach. Mm-hmm. Yeah, they're in Herman. Yeah, that's the little standby. More to come. Herman's going to show you all of these. It's you can ask for a waiver. You can ask for a equivalency demonstration. Equivalency, a demonstration of equivalency. You can ask for an alternative monitoring plan, or you can ask for an alternative means of emissions limitation. And different pieces of the rule will bounce you to those 4 words. No. There's, that's the problem. There is not until MAC-CC. I think what the linkage here and why this is all coming up is in MAC-CC, they formalize the process to ask for something different for your flare. And that is this big, drawn-out alternative means of emissions limitation, which requires passive testing and all kinds of other interesting things. It's a huge request. And the reason I'm bringing it up, and I want you to know about the 4 options, and Herman's going to do a talk on it, is because I think that's excessive, in my humble opinion. Every request doesn't need to be the most stringent that requires a Federal Register notice.
Well, now, will they let you use a data set that's similar to the situation?
Awesome question. Great question, and that's the big trial balloon that's in front of us that we all get to see. So today, on the table for comment is who'd I give it to? I gave it to John back there. John has my copy of the, there is a proposal in the Federal Register. It's only 8 pages long, came out Friday, and that presentation has Dow data, field data, and marathon data from a test done at Johns Inc. on the burner type. So it has physical data. Exxon has no data. Exxon is just using they're using the words of an equivalency based on prior test that the EPA already has. So don't make Exxon test again. We already have a test. And here's the other people who've tested the same thing. Maybe not on exactly the same gas, right? That's the whole, it's a chemical plant gas instead of a refinery gas or vice versa. So the reason the Friday thing is so critical to all of us is, will they authorize an AMEL without a test to Exxon? I mean, more than likely, they're going to authorize one to Dow. Will the public comment period say, hey, no problem with Dow, but we got a problem with Exxon, we want them to do a test?
Okay, so now they grant this Exxon Dow.
Now we have precedence. Woo!
So now I want to do it.
Yeah, now somebody else may have a ground flare or pressure-assisted flare, and they want a tip velocity allowance. And why test it again? We've already done it before. That's the hope that EPA will see.
And everybody here needs to comment on that issue.
Comment, if you agree, in the positive, that utilization of a prior test for Exxon's purpose should be allowed.
Well, good Lord, that's what they've done on that 60.8.
They rely
point from one test to regulate the entire industry for 30 years.
They rely on prior test data. Industry should be allowed to rely on it too. Unless, of course, they come up with some wickedly bizarre new design. And I know the guys at Zinc and Zico are super crazy smart coming up with cool, fun designs. But every flare tip in the world doesn't need to be tested, I wouldn't think. It'd be great, but
when we first started out doing the marathon, we thought that might be a possibility, that flares had very different performance characteristics. But it turns out, I mean, all the steam-assisted flares that we tested, I know the flare guys don't like to hear this, but it doesn't matter what tip you have. It doesn't matter what you're burning. They all follow pretty much the same performance.
Yes.
Now, for air flares, it's different than steam flares, and for pressure assist, it's way different than the other. But the data doesn't support the fact that you have to test for every
one
kind of tip. It's just not necessary.
But to have reliance, if another industry has a pressure-assisted flare, they should be able to rely on the precedent of prior tests. I think that's a great thing that we should be positively supporting. All right, really fast. More NSPS Subpart A stuff. Hard to believe that Subpart A is lasting so long. Don't worry, the rest are a little shorter. Semi-annual excess emissions reports. I think everybody knows about these. It's not just the excess emissions, it's the monitoring system. So what we're seeing now is in J, for the refinery sector, they have to do a semi-annual report. There's a linkage back to 60.7 for what that monitoring performance report has to include. So just remember, it's not all in JA, it's JA and A. Yeah. And the performance testing, again, is only if required by another NSPS subpart. By the way, the updates to JA clarify that, yes, the flare needs a JA performance test. So if you weren't busy enough in between now and November getting your flare management plan and everything else done, your JA flare is now an official affected facility in November, right? It's official. You now have a date clicking for doing a performance test. Many of the refinery guys, I think, have missed that. Great opportunity for you if you're a stack tester. All right, can I be done? Anybody have questions for me on the intro? How's that? My heavens. Yeah, think about that. You're the good point. There's 510, 513. We always lose count roughly. How many refinery flares are there? There've been a couple new ones built. So maybe 510, 512. I can't remember. What do you think, Herman? Some taken out of service as well. That's true. So around 510. We thought the number for JA affected flares is around 300 that are getting the flow meter and the analyzer. That leaves quite a few flares untouched. Lots of opportunity for analyzers and flow meters under max CC, right? Max CC covers all 510 of them. So what you may have gotten out of under JA, you're now back into the game under max.
Those 300 flares all need performance.
Yeah, within the 180, within 6 months.
The question is, what's the maximum production rate?
Right, yeah. We have.
If your units are operating at the normal rate, do you have to do that test within 60 days?
It's worse. It's worse, Theron, because in the performance, in the methods, it says that the unit being tested must be at least running at 50% of maximum load. So it's written again for the perspective of a boiler. I'm testing a boiler. I don't want my flare at 50% of maximum load. Yes, for rata testing.
90% for a performance test?
I think
talking
that's,
about performance.
yes,
And
yes,
there's a very significant
yes,
difference.
yes.
So a performance system,
Yes.
I guess the question would be, if you have your units already online, and they're already running, you know, at maximum rate, of course, what refinery wasn't 2 months ago, and now they're different, but you know, do you have to do that test within 60 days? So, I mean, that's the question you have to ask. I don't really know what the right answer is, but if
Yep.
you want to be covered, you ought to be doing that test within 60 days.
Yeah, and I'm not a super expert on performance testing. I know, Scott, there's other people in the room who are much more up on these things, but I always get stuck on this or 60 days of maximum production or 180 days of startup. What's the startup of the flare? And we always get confused over the JA definition of startup. Was that when the contract was issued for construction? I don't know. I always get confused on all that stuff. Herman has to sort me out. All right, am I done?